please take your seats.
Yes.
Good morning. Welcome to the August 5th, 2025 meeting of the Technological Advisory Council. My name is Martin Doscat. I'm the designated federal officer for the TAC. You might be wondering why I'm introducing the meeting and not the TAC chair. If you recall, at the last meeting, our former chair stepped down. Our charter expires on September 5th, and so this is the last public meeting of the Technological Advisory Council for this charter. And for everyone, a reminder that recently we put out a public notice announcing the intent for the TAC to continue, and we're seeking membership applications. The public notice was released in July. It's on the Commission's website, and the applications are due by October 3rd. Anyone who is in the TAC currently will also need to reapply, so please, a reminder for the folks who are in the room. With that, I'd like to introduce speaker for today, Chairman of the FCC, Chairman Brendan Carr.
Thanks so much. Great to be with all of you. Great to see so many familiar faces. As was indicated, the rechartering and nomination process is underway. You know, serving on FCC advisory committees is a bit like a pie eating contest where the prize is you get more pie at the end of it. So for all of you that have really enjoyed this work, we look forward to hearing more from you all. But, you know, stepping back, obviously I want to, at the outset, express my thanks and appreciation to all of you. As I say to these advisory committees almost whenever we meet, you know, you all obviously have very big, very important day jobs. I can see from your nameplates, you all work at very impressive places, and you're taking time away from that to give back in a form of public service that's going to benefit the American people. And so I want to thank you so much for your time. Obviously, I think what the TAC does is incredibly valuable. The TAC started out way back in 1998. The TAC has lived through many, many different technology transitions, and your work is just essential. It's foundation to the FCC's ability to make sound, forward-thinking decisions in what is increasingly a rapidly changing technological landscape. From our perspective at the FCC, the TAC is a bit like the Commission's early warning system when it comes to big technology changes, and it's also our innovation compass, helping us navigate all of these different shifting transitions in technology and the commensurate changes in regulation that's necessitated by that. You understand the science behind all of these emerging technologies, which is a lot more that I can say for many, many other people that are out there. You guys really understand this stuff, and you ask the hard questions before those technologies even hit the market. We've seen this in action before. Your early input helped pave the way for the FCC's leadership in 5G spectrum policy. I think it's safe to say I don't think we would be where we are as a country without the legwork and the input provided by the TAC. That same kind of strategic foresight is what we now need as the country looks ahead to 6G. 6G is not simply a faster version of what came before. It's going to enable entirely new paradigms. We saw that with the transition from 3G to 4G, which helped unlock the app economy and secure U.S. leadership in that space. We saw it with the transition from 4G to 5G, unlocking all new applications, including, not as much buzz around it, but competition for in-home broadband, where so many Americans for a long time felt like they had one or no choices for high-speed in-home internet. The capacity, the speeds, the latency, performance requirements for 5G really helped open up that market to new competition. We're seeing lots of benefits from that. We're going to see a similar transition take place with 6G as well. That's why your contributions on spectrum efficiency, on AI, taking a look at intermodal networks, on cybersecurity risks, your work there is already helping to shape the contours of 6G policy for the country. Your insights are helping the FCC consider how to foster innovation while always making sure that we're protecting the public interest in this new hyper-connected world. So thank you again for your time, for bringing your talents to the agency, for your public service. You're doing work that truly matters, not just for us at the FCC, but for the country as well. So I wish you all the best in today's productive discussions. I look forward to everything that you all build in the years to come, and look forward to continuing to work with you. With that, I'm happy to pause for a second if there are any sort of quick questions, or we can end my filibuster and let you all get back to the work before you. Ira, anybody? All good? Good. All right, I'll be around for most of the day. I look forward to catching up with you on some of the breaks. So good to see you all. Thanks.
Thanks, Chairman. With that, if there are any other opening remarks, Ira?
Sure. Good morning, everybody. It's great to be here. Good to see everybody for a change. Just wanted to say, with this meeting and the presentations we're about to hear, I think, I'm in particular, I'm really excited to hear everything you've been working on and see what your recommendations are to really help us kind of move forward. As I think the chairman just said, all the work that you're doing is just so relevant to the stuff that we are working on and is coming before us. I think everybody's aware of some of the things that have been happening recently. We've got our auction authority back. We've been directed to repurpose a whole lot of spectrum, for advanced telecom needs. We're looking at satellite usage. We're looking at AI and drones. Some of this is directed by executive order, and as I mentioned, in the budget bill. So, and all of these things, it's just so happens are things that you guys are looking at, talking about, and going to present on. I mean, we've got the 6G working group, advanced spectrum sharing, and AI ML. So all of these things, I think, are going to help us in order to kind of see where we're heading, how to help us make sure that we keep the U.S. at the forefront of the telecom industry. So, with that, I'm going to cede the floor and just really want to hear what you guys have to say and see what recommendations are that we can act on and keep moving the ball forward. Thanks.
Thanks, Ira. Sean, anything?
No, I'm good.
Okay. All right, with that, we'll go ahead and get started. So today's agenda starts with the 6G working group. So if Brian or Manu are there, please go ahead. The floor is yours. I think we're having a little bit of a mic issue.
Well, Manu, I think they want us to speak, but
Brian,
they,
I can hear you. Yes,
can't
Brian and
hear
Manu, are you
what's
available?
happening in the room.
Same boat as you, Brian.
I can hear you and Brian now.
Oh, we can hear you now.
Okay, hi. Yeah, the audio was muted up until now from the room.
Okay.
Harley Cooper here. Can you hear me?
Is now joining.
I can hear you. Yes, I can hear you, Marty.
Yeah.
Brian and Manu,
I
you're up.
think we can all talk to each other.
Well, anybody got something important to say?
Good to see you,
Marty, do you mind going on mute while Brian and I present? Just you have a hot mic.
Okay.
Brian, you want to get going?
Sure. Yeah, just checking. You can hear us in the commission room, right?
Yes, we can hear you.
Yes.
Okay, very good. Yep. All right, we'll go ahead and get started then. Well, good morning, everybody. On behalf of Manu and myself, we'll give the 6G working group readout and report. So we can move to the next slide, please. Guess I have access to that. So we had a very large team for this very interesting topic of 6G. We had good representatives from across the industry, everything from infrastructure to devices to other key stakeholders within the 6G ecosystem. We also want to thank the many FCC liaisons that did help us with this task of producing the report for 6G. For the agenda today, we'll do a quick review of the charter and some of the topics that we covered over the past year. We'll review the 6G working group report, and there are some of the main areas are standards and global positions, industry vertical needs and use cases, as well as enabling technologies. Then we'll have the advisements and recommendations from the working group, followed by just a summary of the subject matter expert presentations we had during the development of the report. So a quick review of the charter. The 6G working group key tasks and focus areas, we boiled those down into the areas that we covered during the tasks of the working group. We did monitor the development and deployment trends of 6G. As you're probably all aware, 6G is in the early phases, so there isn't much as far as deployment yet. But we are in the early stages of standards development, and we'll talk a little bit about that on a few slides from now. We will provide the Commission with technological and regulatory insights from this early development. We did also assess the openness and customization benefits, looking at flexible, agile services and coexistence with 5G. Identify infrastructure needs and recommendations for proactive Commission actions, as well as tracking 6G progress and standards in international fora, highlighting consensus and disagreements that have been occurring as the standards are being developed in these early stages. We did compare competing 6G visions and technological expectations among operators. We did look at some of the emerging technologies such as small satellite development, NTN, and the associated frequency bands, as well as the envisioned services for these technologies. We explored opportunities for millimeter wave and terahertz band utilization in 6G. And evaluated 6G enhancements for verticals, including autonomous driving, AR, VR, edge compute, and emergency alerting, as well as smart cities. We looked at privacy, security, ethical, and social risks, especially when we're talking about massive data collection and emerging applications like the brain-computer interface and holography. We did ensure data and identity security across scenarios, looking at distributed ledger, physical layer security, distributed AI/ML, VLC, terahertz, and quantum communication. And finally, we did look at the plan for 5G 6G support of massive mobile IoT and XR device volumes with low latency, as well as seamless connectivity for near real-time and real-time applications. I won't go through each of the charter topics that were originally presented to us by the Commission in our charter for the working group. But as you can see, when I talked about these on the previous slide, we covered a good majority of them. So diving into the working group report, some of the key insights are the current status of 6G. It's very early into the 6G development trajectory. Standards study items have only recently started within 3GPP. There is still some work on the performance requirements that are being done in the ITU as well. And those roadmaps and requirements are still being developed in these global SDOs. Some of the key insights, we do have recommendations on regulatory considerations, spectrum allocation, and security and privacy risks, as well as emphasis on openness, customization, open interfaces, and vendor diversity for flexible as well as 5G coexistence. 5G is not going away anytime soon, so the coexistence between 5G and 6G is one of the considerations. And there is progress noted in standards development and international collaboration, especially when we look at 3GPP as well as the ITU. There's going to be a need for continued work in many areas. As ITUR, Working Party 5D, as well as 3GPP progress in their studies and the recommendations coming out of the ITU. Those are still being developed, so continued work to monitor those areas are important. There is a lack of detailed comparison of operator visions and expectations. Most operators are still in the midst of their 5G deployments.
Is
and,
now
and
exiting.
and have not considered the implications of 6G. So what those visions and expectations are, they're just being developed by operators, and detailed comparison of those visions and expectations as we move forward would be important. There's been an insufficient exploration of millimeter wave and terahertz spectrum use, and especially what the use cases are, especially as you move up into the terahertz region. There's limited technical details on localization, beam steering, and meta services, and the privacy and security risks from some of the emerging technologies that 6G will enable. Already mentioned BCIs and holographic communications, but also AI and AIML, as well as quantum communication. These remain underexplored and somewhat unknowns as we move into those emerging technologies. There is the need for detailed use cases and infrastructure for vertical industries, especially as we look at smart cities, autonomous driving, and AR/VR. And as mentioned, the small satellite and non-terrestrial network integration does also require further study, as that is one of the other emerging technologies. There are ethical, equity, and psychological impacts on some of these applications of 6G that haven't been fully addressed, as well as security frameworks like quantum-resistant cryptography and AI threat detection, and they lack some of the implementation details. So looking at the road to 6G, 5G and 6G had some growth challenges and future opportunities. Right now there's over 2.25 billion global 5G connections, and it's growing 4 times faster than 4G initially. In North America, we definitely have leadership in 5G with 182 million plus connections with advanced low, medium, and high band deployments. Some of the key use cases that have emerged include fixed wireless access, which do expand broadband access, as well as enterprise applications looking at logistics, healthcare, manufacturing that are gradually emerging. The network evolution, there has been the shift to 5G standalone. We started the 5G deployments with non-standalone, but operators have been doing the shift to 5G standalone for the enhanced security, flexibility, and low latency that is critical for industries. And we do continue with the spectrum challenge. We do have mid-band spectrum scarcity, which does threaten innovation, and it does call for policy to open more spectrum, especially in the mid-band spectrum range. 5G is an infrastructure. It's a backbone for the digital economies, and integration with satellite networks is going to boost coverage and resilience. And finally, looking ahead, the success will depend on smart policy, infrastructure investment, as well as stakeholder collaboration. As you see on the chart on the right, for mobile network operators, spending growth has far outpaced revenue growth since 4G. So operators are spending more to deploy the 5G networks than the revenue growth gains that come along with that. As we look to 6G, we are unlocking the next generation of innovation. We do need to overcome legacy 5G deployment issues and skepticism about cost and complexity that surrounds 5G. Also shift from the speed boost to real customer value and operational improvements. What is the value as we look towards 6G? And with that, what new business models, how can 6G applications be monetized, especially when we look at AI, sensing, and network virtualization? How do we expand partnerships beyond telecom? The infrastructure investments obviously are going to be something to address to accelerate, Open RAN and XRAN, fiber upgrades, and green energy for 6G readiness. And we also need to build skills to capitalize on 6G opportunities. So we need the talent in order to develop and capitalize on some of these new applications and realize some of these new business models. Some of the key drivers for 6G, immersive intelligent user experiences, new revenue streams through advanced capabilities, operational efficiency and energy savings, support for vertical industries, and just to name a few being healthcare, manufacturing, and smart cities. The ecosystem expansion via cross-sector partnerships, as well as commitment to sustainability and eco-friendly networks. As far as the global 6G landscape, there is, increased complexity due to geopolitical tensions and technological dependencies. The telecom industry is viewed as critical for national security and economic competitiveness, and there are major government investments worldwide that are prioritizing 6G research and development. The geopolitical dynamics are going to drive 6G strategic importance. There are differing national priorities as you look across the globe on 6G, looking especially at security, sustainability, and societal impacts. There are also strong public-private partnerships and international collaboration, which is going to be essential to maintain leadership as we move toward the 6G era. And spectrum management and regulatory frameworks is critical. And again, some of the emerging themes are AI integration, energy efficiency, and digital inclusion. In the U.S., there is strong support from the National Science Foundation, Department of Energy, NIST, and others that are targeting some of these new innovative technologies, including terahertz, AI, and network architectures. There is an emphasis in the U.S. on public-private partnerships and international collaboration balanced with security. We all need to prepare for spectrum allocation and regulatory frameworks for 6G, especially as we approach the World Radio Congress in 2027. The NSF has a number of flagship programs, including the RINGS, which received $40 million grant from the foundational research, as well as VINES, which focus on vertical industry adoption and use-inspired research. And of course, the flagship is the ADIS 6G Alliance, which is the industry-driven consortium advancing North American leadership in 6G R&D standards and commercialization. And the 6G Alliance has refocused as the 6G studies have begun in the standards to focus on technology roadmap, sustainable development, market and applications, as well as spectrum. The EU has significant funding via Horizon Europe, and again, they're focusing on some of the key aspects of 6G, which I already mentioned. And their strategic goal is to reduce dependence on non-EU suppliers and foster a strong European telecom ecosystem. There is Smart Work Networks and Services joint undertaking with over 1,000 organizations that are collaborating on 6G research and investment roadmaps. And there also is the Hexa X2 project, which advances 6G system design and global standard harmonization with goals, again, on sustainability, inclusion, and trustworthiness. Japan, their vision extends beyond tech, targeting societal impacts in healthcare, disaster prevention, and environment. And they have a goal for commercial 6G launch planned around 2030 with prototypes by 2028. This is led by the Ministry of Internal Affairs and Communications. And they do have an XG Mobile Promotion Forum, or XGMF, that does drive 5G and beyond 5G research and development. And they do have a focus on network for AI and AI for network, both at data infrastructure as well as autonomous optimization. And there is also the IOWN Forum Vision 2030 which emphasizes cognitive capacity, responsiveness, scalability, and energy efficiency. South Korea has their 6G Forum Korea, again looking at global leadership evolving 5G towards 6G. And their Ministry of Science and ICT did launch the 6G Society to enhance tech exchange between mobile and satellite communications. And again, they're targeting operational 6G service by 2028, and they're among the fastest globally as far as their aspirations. India has the Bharat 6G Alliance, which is an industry-led government-facilitated platform supporting their Bharat 6G vision. Again, the focus is on device diversity, equitable access, cost efficiency, and sustainable development. And it is a collaboration among public, private sectors, academia, research, and standards bodies. And in China, 6G is part of the 14th five-year plan, new infrastructure initiative. There's heavy state funding for terahertz satellite, quantum, and AI, as well as expanding 5G, IoT, cloud, and industrial internet with smart infrastructure. The Ministry of Science and Technology leads a coordinated 6G R&D effort since 2019, and they also have their IMT 2030 6G promotion group, which is an industry, academic, and government collaboration on research, standards, trials, and global cooperation. And the chart you see here lists all the companies that are involved within that IMT 2030 6G promotion group. In the Middle East and North Africa, the UAE has a comprehensive 6G roadmap aligning with the UAE Centennial 2071 and 2031 plans. They do have a focus on digital transmission of human senses, robotics, healthcare, AI, and autonomous transport. They do collaborate with global bodies, including the ITU, IEEE, 3GPP, as well as getting regulatory support with Spectrum and Sandbox initiatives. Again, the emphasis is similar to what other regions have indicated on digital inclusion, sustainability, and security, and they're targeting their 6G deployment by 2030 as well. Saudi Arabia, again, has a strategic partnership to accelerate 6G deployment aligned with Vision 2030. The focus is on AI-driven networks, spectrum trials, cloud infrastructure, and sustainable energy-efficient solutions. And they aim to be a regional digital hub influencing global 6G standards. As far as the standards update, 3GPP obviously is the flagship for standards development for 6G. They do have key releases planned through 2030 and are the leading global standards body for 6G technology. They are in collaboration with other global stakeholders, including operators, industry, as well as the ITU. And they have recently had collaboration with the O-RAN Alliance to ensure cohesive ecosystem development between the Open RAN as well as the 3GPP architecture. They aim to build on 5G lessons with simplified, resilient, and efficient systems. When we look at the timelines, 3GPP Release 20 are the initial studies and requirements for 6G, and that release has already started and will complete in 2027. Release 21, which will complete by 2030, the timeline is still TBD in 3GPP, but that will be the first formal 6G technical specifications and also will have the alignment with the IMT 2030 performance requirements. In May of 2024, there was the initial 6G workshop that had a number of themes, including security, focusing a lot on quantum safe methods, as well as AI for network optimization, energy efficiency, and smart applications, immersive communications, including XR holography, digital twins, and metaverse, sustainability, ubiquitous coverage, which includes satellite and non-terrestrial networks, as well as disaster resilience, as well as sensing, environmental and contextual awareness and integration. Also, there was a 6G workshop, Vision and Goals from the 2025 workshop. Again, many of the same themes. Won't repeat them here, but they're spelled out on the screen. Some of the lessons learned from 5G and motivations for 6G. 5G, there was complexity from multiple architectural options, particularly the non-standalone and the standalone. That NSA to SA did provide some transition challenges for operators. There was also a slow uptake of features like network slicing. So the lessons learned is there is a need for a simplified, modular, and scalable 6G design. Some of the focus areas for which drive the motivation include cloud native and AI native network architecture, spectrum efficiency and exploration of new mid-band frequencies, integration of terrestrial and non-terrestrial networks, service-aware programmable networks for diverse use cases, preference for single standalone architecture to reduce complexity, and you don't have to go through that non-standalone to standalone transition that pose challenges for operators in 5G. A modular, scalable support for devices, services, and spectrum, and the built-in enhanced security and privacy from the start. The other aspect is openness on day one, and that is working between 3GPP and the O-RAN Alliance to ensure that an open RAN architecture and a 3GPP architecture are complementary. The motivation and use cases for 6G include new services. Integrated sensing and communication is the one that is most promising as far as new services as we move into 6G. There is also immersive technology, looking at how to monetize network and provide diverse industry applications, as well as the core principle of energy efficiency and sustainability. Well, with that, looking at some of the, again, some of the potential drivers for 6G, coming out of the 3GPP 6G scenarios and performance study, they looked at different deployment scenarios, including not only the urban macro and dense urban areas, but also indoor, rural, and air-to-ground and non-terrestrial networks, looking at different frequency bands from the frequency ranges from 700 megahertz to 30 gigahertz, as well as some of the performance targets for latency, spectral efficiency, connection density, traffic capacity, and the emphasis on sustainability, resilience, and seamless 5G migration. The 6G use cases and service requirements document, which is being developed by 3GPP SA1, has a target completion date of early 2026. And again, much along the same themes, looking at network resilience, predictive maintenance with sensors and surveillance systems, balancing computational load and power consumption in urban networks, exploration of digital twins for autonomous network management, mobile edge compute and collaborative aerial robotics, critical infrastructure resilience strategies, as well as new radio-based sensing and non-3GPP sensing services. The O-RAN Alliance and 6G, driving open, intelligent, and flexible networks. Again, advancing openness and modularity between 5G and 6G RAN designs, developing AI/ML frameworks for real-time network optimization, automation, and self-healing, evolving cloud-native virtualized architectures so that we get scalable, distributed, edge, and centralized deployments, as well as supporting emerging 6G use cases in the Open RAN, including holographic communications, ultra-low latency, massive IoT, and terahertz. The O-RAN Alliance is collaborating with 3GPP so that they align Open RAN solutions with 6G architecture and standards for seamless ecosystem integration. 3GPP will define the overall 6G architecture as well as the air interface and core network specifications. The ORAN is going to focus on the front haul interface, the service management and orchestration architecture, as well as cloudification. There will be joint efforts between the two organizations to align AI ML frameworks as well as the security architecture. And the whole goal is to make sure 3GPP and ORAN specification development are complementary and they avoid duplication, ensure unified specifications, and foster innovation. Some of the key collaborative focus areas, again, are the 6G front haul interface, which have split responsibilities between the two groups, AI/ML, and the coordination that is needed to make sure we have coordinated lifecycle management and automation services, the SMO and automation, diverse division of management, architecture, and services, cloudification. The ORAN will lead the network function cloudification as well as security with a coordinated, consistent 6G security measures. The ITU, the draft recommendations establish the framework and overall objectives for IMT for 2030 and beyond. There are 6 key usage scenarios for future mobile technologies to specify the minimum performance criteria and KPIs, including those listed here. They will also provide test methodologies and evaluation criteria that will come about as we move closer to 2030. And the timeline has been established for the IMT 2030 standardization progress. And again, it all ties to having the evaluations complete and specifications developed in the 2030 time frame. Just for completeness, we included the wheel and pallet diagrams, which do show the usage scenarios and capabilities for IMT 2030 that have been developed by the ITU. Again, I'm not going to go through these in detail. They are published by the ITU in their vision document for IMT 2030. And there are also the 9 trends that are viewed by the ITU for IMT 2030. The IEEE also has a role in 6G research and Wi-Fi evolution. They do have conferences, workshops, and publish research on key 6G technologies, including terahertz, AI, and advanced network architectures. They help shape the foundational technologies that will influence the future 6G standards, and they do work in collaboration with both 3GPP and the ITU, as well as the ORAN Alliance. They do host technical committees on spectrum management, virtualization, sensing, security, and sustainability. They do facilitate academia, industry, and government collaboration. And some of the emerging Wi-Fi trends that we'll see in the 6G era include seamless convergence with 5G and 6G for hybrid connectivity, as well as Wi-Fi sensing for motion, gesture, and biometric detection, mesh and distributed architectures so we can enhance coverage and resilience, looking at terahertz spectrum for ultra-high bandwidth and low latency, as well as AI-driven adaptive network management, energy-efficient designs for IoT devices, and scalable, secure support for massive IoT deployments. Well, with that, let me turn it over to my co-chair, Manu, and we'll talk about some of the industry vertical needs and use cases.
Thank you, Brian. Good morning, everybody. Apologies for not being there in person. Manu Gosain here from Northeastern University, and I'm going to sort of switch gears a little bit. We've heard about the standardization roadmap that's ongoing. We want to sort of shift focus and peel back how kind of the 6G visioning is being discussed within the industry and within the standardization development organization. So similar to 5G, the focus has been around promoting new use cases and meeting different industry vertical needs, and from there backing into the different enabling technologies. So just to rewind the clock, 3GPP did kick off the 6G planning with a first use case oriented workshop, which Brian referenced in a summary chart we got from the Next G Alliance, where all the different use cases and special interest groups were represented. So we're going to highlight a few that the TAC working group has gone through, and we're going to focus on some that are evolutionary, which are kind of moving from needs that were met in 5G and some needs that will be met in 6G, but then some of the newer use cases, which initially you just saw on the wheel and palette diagram. Next slide, please. So we'll start with sustainability. So it's not necessarily a KPI. It's viewed more as a KVI, a key value metric. Sustainability is being looked at as a core design principle across all different usage scenarios. So sustainability from the perspective of end-to-end energy efficiency, being more energy efficient than 5G. And then obviously there is always a trade-off around sustainability in terms of the benefits that it provides versus the costs. So how can we increase the benefits and reduce the costs? There are different factors looking all the way from environmental, which is obviously as energy efficiency and power consumption is reduced, as well as kind of enabling new use cases around precision agriculture. On the social side, digital inclusion, access, bridging the digital divide, and enhancing the network reliability, resilience, and trustworthiness. And on the economic side, adding basically newer use cases to kind of increase and broaden the aperture of the economic impact that 6G can have in terms of making the network become more sustainable from a mobile network operator perspective. Next slide, please. So automotive and autonomous driving, those that have been observing 5G, this has been one of the success stories in terms of being able to deploy and enhance 5G for providing coverage for the automotive sector. Current focus obviously has been on vehicle to infrastructure, but also a little bit on the vehicle to vehicle side. On the 6G side, key new enhancements are going to focus on the meta surfaces and the reconfigurable intelligent surfaces. So basically the body of the car, as you can see on the figure on your right, being leveraged for enhancing the signal that could be used or utilized inside the vehicle for providing coverage. ISAC is going to be also a key use case that will support the automotive sector in terms of providing sensing and communication on the same channel. There will be integration with the TN and NTN. We are already seeing some advances in the 5G domain with direct to device, and how does that get incorporated into the automotive sector is something that the 6G is going to continue to work on. 5G AA, which is kind of the special interest group that represents the automotive sector in 3GPP, etc., focused on secure, resilient, and low latency communications, so primarily the URLC factor, which is going to continue to be important and will be developed for this sector. Next slide, please. So emergency services and public safety, this is important primarily in the US, obviously with the role of FirstNet and increasing kind of building on top of what 4G and 5G networks have been able to provide. With 6G, the idea is obviously to maintain and support the legacy infrastructure in terms of backward compatibility, enhance trust, resilience. This is primarily related to the security of the networks. And as we enter a post-quantum world, providing post-quantum security and post-quantum safe security metrics and measures for both from public safety perspective, as well as for delivering emergency services. Is going to become important. FirstNet itself participates and is involved in the standardization and standards development process. But in terms of our interactions, the idea is to sort of support how to analyze and manage the large swaths of data in different modalities, whether it be video, whether it be text or different streams that need to be consumed to provide intelligence and decision-making capabilities at the command center level. Features obviously to support the streaming from the live body cams, as well as massive IoT device connectivity, and also supporting the 4.9 gigahertz, which at least in the US is a dedicated band that is available for purposes of public safety as well as to the Department of Homeland Security. Next slide, please. Smart cities will continue to become important. The 6G improvements, again, a little bit more more incremental, but also in terms of providing broader coverage. So this is going to be a play around balancing coverage and capacity in terms of making sure that services and the broad variety of sensors that are deployed around to provide kind of smart city applications can be supported by 6G. AI native support for infrastructure management, leveraging ISAC for using UAS for detection of different for predictive maintenance and different operations, leveraging the legacy infrastructure that will be deployed as 6G is introduced into the market. The idea for smart cities, obviously, from a self-healing infrastructure perspective, as well as providing environmental monitoring and diagnostics of different kind of critical infrastructures, as well as public planning and public infrastructure that the city town infrastructure teams have to maintain. Next slide, please. This is more on the, again, NTN has been in the conversation in 5G, specifically from, release 17, et cetera, onwards, and there has been a lot of work. But with the IMT 2030, this becomes, this was pulled up in the wheel as kind of a individual first order citizen, so to speak. So beyond the triangle of EMBB, MMTC, or URLC, we're seeing ubiquitous connectivity, which primarily includes a very keen and strong focus on non-terrestrial networks in terms of improving coverage, as well as being a supplemental heterogeneous access technology to the 6G terrestrial network. And also as the regenerative mode of NTN architecture develops, the idea that G-Node Bs at different stratospheric heights, whether it be on the LEO, MEO, GEO, and GSO side, will become very important. So current advancements, obviously direct to device has been enabled by a few different mobile network operators and increased in the number of different constellations, as well as the current 60 megahertz report in order that's coming out of the FCC in terms of the command channel for maintaining UAS operations. So that will be quite interesting. Some challenges, obviously, around device cost in terms of swap, which is size, weight, and power, in terms of maintaining a lightweight 6G G-Node B on an NTN base station, as well as maintaining this the new kind of regenerative mode beyond just a transparent dump pipe mode that is available right now. Next slide. Digital divide is quite important. This is something the FCC works on, and this particular working group is quite passionate on. So the idea is around 6G is to have digital inclusion in terms of expanding access and coverage. This relates to some of the sustainability goals in terms of lowering the cost of access and providing affordable devices, and as well as kind of enhancing the fixed wireless access use case, which no doubt was one of the few shining lights in terms of the early 5G deployments and providing some of the initial impact of having 5G services. So how do we continue to scale? How do we use massive MIMO, giga MIMO that's being discussed in a 6G context? And obviously balancing that with access to spectrum, site density, as well as the customer premise equipment, which will need to be important so that 6G is available outside of major densely populated urban areas. Next slide. Agricultural application. So this is a two different things. We're looking primarily at precision agriculture, which is around helping improve farming practices, as well as providing sensor fusion, different modalities that exist in the field, in the farm, thinking of a network as a service on the farm, increasing the deployments of UAVs for predictive maintenance, for spraying the crops, and also for providing autonomous operation of the larger farm and infrastructure equipment that could be done with a high reliability as the 6G architecture evolves. Ambient IoT, initially, so kind of a little bit more on the newer side, but this is kind of looking at a battery-less idea of powering the wireless sensors that are in the field. In an agricultural sense, when you're burying the sensors in the soil, having a power source is very hard. So kind of thinking about ultra low power sensors that can be just left in the field. And in the ambient IoT case, also the idea is to address the low complexity beyond the narrowband IoT capability, as well as trying to also support the personal equipment for public safety officials as it pertains to the use of ambient IoT and how this will be connected, if not developed in 3G, adjacent to it. Next slide, please. ISAC we've used as a use case. This is kind of one of the more novel ones, at least in this initial conjecture and discussions, including some of the use case discussions that are happening in 3GPP. This is emerging as a very important thrust and a pillar. Obviously, the technology we'll discuss a little bit later, but it's just combining both communication and sensor modalities. The idea is to do radar-like detection and localization, but the idea is using a communication signal and enhancing it somehow. 3GPP and ETSI have been very busy, published a ISAC use case report. So this has about 16 or 18 different use cases that have been published, both outdoor and indoor. So this is again looking at it from the perspective of public safety, monitoring, collision avoidance, UAV detection, perimeter protection, and in indoor cases, gesture recognition and the protection. This will introduce some interesting new challenges, specifically around spectrum usage, as you're using the spectrum now as a sensor instead of communication, and how much of that spectrum is available for sensing, because this will increase the resolution of the sensing. So interesting policy questions will come up. For the FCC, privacy initially will be very important, because if you have a network that can passively sense you, how do you maintain and protect personal privacy, and how do the network operators maintain privacy profiles, or are responsible for the data that's collected and who it is or is not exposed to in terms of liability, and maintaining some of the rules and regulations that the FCC has in terms of personal protection. Next slide, please. AR, VR, XR. So this is again continues to be very important. Building off of 5G, this was primarily one of the URLLC, ultra reliability, low latency use case. The applications are around online gaming, multimodal data transfer, services around education, and in the technology side, really with the advances on the graphics side, on the optics side, this will require additional computation on the distributed computing side. So you essentially have to think about compute processing, whether on the device or at the edge, and then how do you sort of split that computation to still maintain the low latency parameters that are needed. More studies are required, but in terms of meeting the goals of having XR experiences as well as hyper realistic visualization will be a very interesting use case for 6G. Next slide. So let's switch focus. So that was primarily our perspective on the different industry vertical needs and use cases. Again, not meant to be exhaustive. The report goes into a little bit more more nuanced and more technical detail around each of these. Now the idea is to focus on some of the enabling technologies that are going to meet the needs of the use cases. Again, remember the ITUR and the IMT 2030 performance requirements are still under development and will be available for SDOs such as 3GPP somewhere by the middle of next year. So these are initially the technologies that are being seeing some level of interest. This was part of our charter, and our goal here is not to obviously describe each technology, but primarily look at it through the lens of what the current state of the art is and what the TAC believes would be the potential for these technologies as they are developed and mature, from whether being ready for day 060 or being introduced a little bit further out as the releases are incrementally released. Next slide, please. Let's talk about terahertz communication and visible light communication. So terahertz, obviously looking all the way to true terahertz, but also sub-terahertz, 100 to 300 was discussed, but also going to 1 terahertz. And obviously the potential is to support the high capacity and network sensing with the large amount of unused spectrum that's up there. Obviously there are some other passive services that need to be thought through, but the idea is that this would be very important. And also in terms of indoor uses, usage, it can provide high spatial resolution from the short wavelengths and the large bandwidths that are available. Extensive research has been done, prototypes are being developed, and a lot of measurement campaigns for understanding how the channel behaves and how coexistence is going to work in this field. Also looking at different materials in terms of how do we build different radios. So looking at technologies such as the plasmonics and photonics, looking at how those advances can be used to build terahertz radios. Visible light, this has obviously been on the fringe, looking at the from the outside in, some work happening in IEEE, but just wanted to talk about using visible light spectrum for data transmission purposes. And right now, the standard does exist in the 802.15.7, which specifies the physical and MAC layer. So in terms of applications and use cases, this is going to be used for vehicle to vehicle, vehicle to infrastructure, and or indoor sensing and positioning and localization technologies. Next slide, please. Reconfigurable intelligent surfaces. So this is important again because it enhances coverage and capacity, does it by a beamforming. So the idea is that you have a larger a large array that can potentially redirect the signal, whether in a passive or an active manner, and can provide flexible spatial reuse. So different modes of risk that are being investigated, and a lot of work happening in the academic and industry bodies in terms of promoting the use of risks and meta surfaces. Advanced waveforms and modulation. This one is still TBD. These are like, how do we adapt the waveforms from beyond what we have today in terms of supporting the midband spectrum to support high frequency bands? And how do we sort of maximize spectral efficiency, robustness against interference, especially as the networks get more and more dense, as we look at spectrums, not just at millimeter wave and terahertz, but also at FR3, and then how will these waveforms modulation schemes enable seamless connectivity across the diverse 6G use cases? Next slide, please. Advanced MIMO. So MIMO obviously was one of the key kind of pillars in supporting the growth and densification and capacity for 5G. So we are now looking at adding more and more, densifying the array, and going up to thousands of antenna, which will enable spatial multiplexing and beamforming, and also combining this with the cell-free architecture, which provides uniform coverage and ultra-reliable connectivity. Challenges are obviously around the deployment, complexity of the system, and the capacity on the front haul side if you are supporting an ORAN architecture. But on the flip side, you do end up getting to support a large number of devices, and including having low latency and high reliability for some of the initial use cases that we have discussed earlier. Next slide. The edge and the cloud native computing. Again, edge computing is not a new or a novel concept. In the 6G in the 6G domain, this is going to become cross-cutting because as AI gets closer and closer to the edge and closer to the radio, edge computing is going to become important because it'll have to support multiple different time loops, all the way from real time as well as near real time. So this will have important implications on how the edge architecture for 6G is going to be defined. Cloud native design continues to borrow from what we have seen in 5G, as well as the cloud radio access network deployments in terms of virtualizing and using microservices and best of breed services like Kubernetes and then containers. Also facilitates a CI/CD system, which allows for tolerance whereby the different implementations of the network elements can quickly be swapped in as the needs emerge. And the synergy here is to optimize the resource use, and the responsiveness in this edge to cloud continuum. Next slide, please. Open RAN obviously is a key enabling technology, and we here combine it with AI. There is a new alliance which we sort of hinted at earlier, but just to reinforce the AI RAN Alliance, which is looking at different kind of ways to introduce AI into the radio access network. So Open RAN is going to become that conduit between what's happening in 3GPP and what's happening in this new industry alliance, because the idea is to develop different use cases that will support or demonstrate the use of AI. There are some that are low-hanging fruit, which easily are around maintaining and manipulating the data parameters so that you can train your models offline and then introduce them online slowly. But also more revolutionary, which is to look at how do we instantiate different kind of workloads and build bespoke and customized networks all the way from meeting the demands on the radio side, but also scaling horizontally and vertically as things are going to progress. Next slide, please. Full duplex communication, again, something that was looked at in 5G, but here some interesting new advances in full duplex. Obviously, the biggest issue is self-interference cancellation, and the idea here is to develop things like subband full duplex, which allow for simultaneous transmit and receive, and combining this technology to increase and amplify the gains received by full duplex by employing larger arrays, going from massive to giga MIMO. Quantum is going to, again, cannot be ignored. So QKD, quantum key distribution, is for unbreakable encryption. So this will be important for government customers such as the Department of Defense that want to employ quantum safe networks going into the future. And the HCQKD group is a place where we need to be paying a little bit more attention if we are thinking of maintaining sovereignty on on our communication networks. Next slide, please. So infrastructure and compute, this is going to be form the basis of how the 6G architecture evolves now with the proliferation of multiple different x86 different based architectures or ARM architectures, FPGAs and GPUs, which are able to host a variety of the different base station functions, whether it be the CU or the DU. There are advances in the material side that are going to support new different chipsets that will be able to host, be performant, and also allow for AI native applications to be supported. So those kind of compute paradigms need to be monitored. And as the AI train becomes more and more mature in a telco cloud, and as telco LLMs become a reality, how are those edge workloads going to be supported is going to be we need to monitor how that technology is going to evolve in the future. Next slide, please. ISAC again shows up because it's not just a use case, it's also the technology. The concept obviously is the radar-like detection and introduction of different capabilities, but also being done with AI-powered processing. So real-time sensing data analysis, collecting different sensor information, and different modalities to do sensor fusion, and how that technology needs to be developed in a standardized way is going to be very important. So different endpoints are going to become distributed sensors, and this does beg the question of privacy and a regulation framework that needs to be looked at. But from benefits perspective, it does enhance the security, safety, efficiency, and awareness in the different applications. Next slide, please. So this one is not necessarily just an enabling technology, but something which is going to become important, which are alternative sources for positioning and timing. So GNSS independence, especially seeing a lot of jamming that happens for the GPS signal and the maturation of other constellations, whether it be GLONASS or Baidu, produced by China, which are complementary terrestrial solutions. On the 6G side, how do we sort of support the role of this layered and resilient PNT system, and then also have different kind of government-sponsored frameworks to build resilience. Next slide, please. Brian covered this a little bit earlier, so this is here for the sake of completeness, brain-computer interfaces. This is focused obviously on the medical sector and advances in wearable and wireless technology, and then the integration of AI. And then on the holographic side, early deployments are being looked at in a private enterprise case with for telepresence. So telepresence, but it does come with different challenges across bandwidth, latency, and the capture and render complexity if the networks are fast enough to support that. And then AI-driven enhancements are still underway for responsiveness. Next slide, please. Energy efficiency, again, to bring this all the way back to our KVIs, the key value indicators. So energy efficiency is going to be very important, and this is being looked at holistically, all the way from efficient processors, efficient radios, antenna architectures, as well as power management, leveraging AI, and energy harvesting to reduce the carbon footprint. Next slide. Security and privacy will also similarly evolve in 6G as the threat surface, so to speak, is broadening. With ISAC, privacy concerns are going to be interesting to deal with. And then on the system side, an AI-powered adversarial attack is going to take down communication networks, which we're already seeing play out even in civilian use cases in conflict areas. Security and privacy is going to introduce, will have to deal with homomorphic encryption, privacy enhancing techniques, and how do we combine the cryptography, AI, and network slicing so that 6G can be sum of its parts. And network resilience is going to be important, obviously, because it detects jamming, spoofing, and is able to easily scale. Next slide. Okay, Brian.
Okay, so let's move focus then into the advisements and recommendations with the theme of driving innovation, connectivity, and the societal impacts. So first is the overview and importance of the FCC engagement. We have proactive and coordinated efforts across the globe, and we believe the Commission must engage across the technical, regulatory, and policy domains to enable a vibrant 6G ecosystem. And again, the key focus areas facilitate innovation while addressing challenges like the digital divide, address technological debates, millimeter wave versus terahertz, localization advancements, for example, analyze privacy and security risks linked to emerging technologies, BCI and holography, as we talked about, support vertical industry needs through detailed use case developments, including those smart cities, AR, VR, and autonomous systems. And as we mentioned, we are in the early stages of 6G, so there is roles that future tax can play, including exploring the divergent operator visions and technological priorities, as well as developing frameworks for emerging spectrum and security challenges. As we look at 6G development and standards evolution, as mentioned, several times, the current status is we're in the early evolution stages with initial standardization studies, and the ITUR performance requirements are not expected until next year. The architecture themes emphasis is on open interfaces and encouraging vendor diversity to reduce the total cost of ownership, and simplification of network interfaces to reduce complexity. So what we believe the FCC's role is to facilitate collaboration among the ORAN Alliance, 3GPP, and industry stakeholders, navigate some of the geopolitical tensions, promote open, secure, and interoperable standards, monitor international standards bodies to align U.S. priorities with global roadmaps. The FCC can play a constructive role in fostering collaboration between the ORAN Alliance and 3GPP, including through the North American organizational partner ADIS. The FCC should also monitor and engage actively with 3GPP, ADIS, ITUR, and other international bodies to align U.S. priorities with the global 6G development roadmap. And again, future FCC TAC working groups should continue to provide advisements and recommendations based on the ongoing 6G standardization work. We also want to promote U.S. leadership and standards influence by active U.S. participation. Operators, vendors, government agencies must influence ORAN and 3GPP processes to shape standards that will align with our national interests. Policy advocacy is important to incentivize innovation, reduce dependence on vendors with conflicting geopolitical interests, promote the open interface and open standards to encourage competition, innovation, and reduce vendor lock-in. And finally, regulatory adaptation to prepare to modify frameworks in response to emerging architecture and interfaces. As far as architecture and technical considerations, 5G standalone reluctance, again, mobile network operators are cautious due to unclear business cases and hardware costs. We want to have interface simplification to consolidate or remove complex interfaces like the CU-DU F1 interface between the CU and DU. We want to do that to improve vendor diversity and reduce operational complexity. We want to favor continuous integration, continuous deployment models over costly hardware refreshes. So we need more software-centric upgrades and less reliance on what we call the 10-year G cycles. And finally, use case inclusion. Incorporate diverse industry vertical requirements to ensure standards relevance and adoption. We also want to promote open interfaces in the 6G architecture to foster vendor diversity and to reduce that total cost of ownership, adapt regulatory frameworks to the evolving standards coming out of 3GPP and ORAN and the collaboration between the two. Also recognizing the impact of industry and national interests on openness and interoperability, and supporting policies that encourage interoperability and open standards so that we do drive competition and innovation. So the recommendation is the FCC should support policies encouraging interoperability and open standards, which will benefit competition and innovation in the network equipment ecosystem. So Manu, let me turn it to you.
Thanks, Brian. So yeah, just to wrap up some of the business case and emerging use cases. So again, as we talked about, the notion here is to develop the use cases and then to develop the technologies that will support those use cases. So focus is obviously on increasing the revenue side, but also focusing on the cost and efficiencies. ISAC seems to be a breakthrough in terms of supporting different kind of use cases, and will be a new paradigm that will combine both communication with sensing capabilities, will require a new network architecture, a regulatory look, and oversight, as well as different kind of monetization models, whether it be providing a network as a sensor or sensor as a service, and how will that be looked at from a policy perspective. So the recommendations are around exploring how this will all sort of come together in terms of sensing, positioning, localization, and will be integrated with the 6G architecture. Next slide. Yeah, the ethical social impacts. Again, we talked a little bit about the brain-computer interfaces, so some of the advancements specifically around healthcare applications and issues around developing technologies that are implantable as well as non-invasive. holographic communications as they transition from demos to practical use cases, as well as looking at the different kind of niche markets that will be supported by this technology. And then the potential for kind of considerations for privacy in terms of equity on where these technologies will be available, as well as the societal impacts will require careful management. Next slide. NTN, as we talked about, again, this is looking at all the way from UAVs and all the way up into the stratosphere between the LEO, MEO, GEOs, NGSOs, and HAPs. So as the rapid advancement of this technology is happening and the integration within the standardization bodies of NTN with the terrestrial network, as well as the notion of providing coverage for 5G advanced and 6G in NTN to provide the benefits of lower latency communication and enhancing the signal strength, these hybrid network solutions will require some of the regulatory implications for unmanned aerial systems, high altitude platforms, and this will require some closer coordination with other agencies, at least in the US, such as the FAA, to develop operational frameworks that are essential to ensure the use of satellite communications as it becomes a primary part of 6G networks. Next slide, please. So non-3GPP technologies, again, we've talked a little bit about Wi-Fi and IEEE. Just to sort of level set, Wi-Fi 8 will be introduced in the next year, and there will be devices that support that technology that will be coming on the market a little bit much sooner than 6G will be available. So how does an enhanced and improved Wi-Fi 8 with additional bandwidth capabilities, modulation coding, as well as itself looking at sensing and positioning work with the 6G architecture? We're also seeing the introduction of MRSS, multi-radio service support model, which will allow, at least right now in the literature, the notion of using 5G bands to provide 6G service. So there will need to be some alignment on the policy and the standardization side to maximize spectrum efficiency and interoperability. And also looking at different offloading strategies beyond just the Wi-Fi offload strategies that we're looking at now. So a recommendation is to consider the development in the unlicensed spectrum technologies as Wi-Fi, but also looking at promoting policies and regulatory frameworks to facilitate the seamless integration. Next slide, please. ISAC, so again, this one is very nuanced. Obviously, some of the use cases for network as a sensor, sensing as a service, will require a newer paradigm of thinking about the different policy and regulatory frameworks. And as the architecture is developed, meeting the needs for spectrum management and interference management to maintain or understand the balance between the spectral bandwidth and the sensing tasks that are being that will be used to provide from the MNO perspective, and then security privacy concerns in terms of tracking and monitoring citizens and other folks to be able to do this passively, and what are sort of the concerns around that, and how are mobile network operators or private network operators responsible for that. So recommendations is to adapt spectrum allocation, develop interference management, device certification, and be a little bit forward looking to foster coexistence, innovation, and ecosystem growth for nurturing ISAC in the future. Next slide, please. Security, privacy, and data governance. So this is going to be, the key recommendation here is to sort of continue to look at the persistent and potential vulnerabilities, and all the way from the radio frequency side for denial of service, both intentional, malicious, and accidental, and also try to tackle some of the spoofing tools that are threatening the trust in location and identity signals, and trying to develop resilient fallback mechanisms for physical and MAC layer. And there is a CISRIC working group which is focused on 6G security. So we'll continue to advise to twin with the work product outputs that are coming from that working group as well. Next slide, please. Spectrum considerations, again, don't need to be specific, but just the notion here is there are multiple bands that will be required for 6G, so low, mid, and high, as well as satellite communications. Understanding how we can provide predictable spectrum access to accelerate the adoption and maximize socioeconomic benefits. So the idea would be to continue to evaluate, do additional band studies, whether it be on FR3 spectrum, mid-band, low band, or high band, and identify the spectrum needs across the different services and balance them between the communication and sensing tasks so 6G could be successful. Next slide. Industry collaboration, cannot say enough about that. There are multiple different bodies that are out there that are promoting and executing the development of the 6G standards. So 3GPP ORAN, ITU-ARA, MT 2030. The idea here is to encourage the FCC to maintain actual and active liaison and participation in these different agencies and to harmonize these specifications, not just from a standard perspective, but also from a whole of government USG perspective. Next slide. Yeah, so with that, we'll stop here. The rest are basically the subject matter experts that came and spoke to us during our time working on the charter topics. So we don't need to go through that. This is just for the sake of completeness. Happy to take questions. Thank you.
Okay, thank you, Brian and Manu. Are there any questions in the room or on Teams? And just a reminder for the folks in the room, if you can flip your tent card sideways if you have a question, and we will be monitoring the hand raise feature on Teams. Start over here with Greg.
I just wanted to ask Manu, when you talked about terahertz and you listed some of the challenges, one of the challenges I didn't see was interference with passive radio astronomy. Has that been considered or ruled out?
Not at all ruled out. Absolutely, that's a good observation and a great point. So in the discussions we had with the subject matter experts that are invited for those discussions, we did take a very keen look at 100 to 300 gigahertz, and I believe that there are certain different comments, and I believe in the spectrum sharing group there might be some acknowledgement of that as well. But no, did not mean to discount that issue. That's going to be very significant to solve.
Thank you.
Over to Monisha.
Thanks, Manu and Brian. Quick question. Towards the end of your slides, I think you mentioned in a couple of slides that the FCC should balance allocations between communication and sensing. So if ISAC is integrated into 6G as part of the 6G technology, how would are you really thinking that you're going to assign separate spectrum for sensing, separate for communications? I thought it was all going to be integrated.
Brian, do you want to jump in? I'm happy to answer too.
Yeah, I think you're probably right, Manish, in that observation is that, the whole intent of integrated sensing and communication is the integration and reuse of the existing spectrum bands that are for communications. But there are some open issues as to whether or not, additional spectrum allocations would be used for some of these sensing capabilities outside of the traditional communications. And again, that's just to, make the commission aware that the potential is there, that could be done, the ISAC functions could be done with additional spectrum allocations outside of communications.
Yeah, I think the perspective was also just to look at, how will this be balanced at a practical level when you're a mobile network operator offering these offering services, whether it's your network as a sensor or a sensor as a service, and how much of that spectrum is going to be offered for sensing purposes, and depending on what kind of sensing, how much bandwidth is, or how big a chunk is offered and depending on what kind of a resolution is required, and that's going to be somewhat proportional to how much of the spectrum can be observed, and that will obviously also be need to be balanced with the coverage and capacity needs. So yeah, I think we just wanted to make sure that it's left, it's not completely solved because the architecture itself is evolving. So we wanted to just make sure that that point is left to be considered as it's still being studied.
Bijoy?
Hi. Under your architecture section, you make a recommendation to consolidate or remove the CUDU interface. At the same time, you talk about adding and improving vendor diversity. Could you explain that? What's the rationale for consolidating and removing the CUDU interface?
I think that was not it's not a recommendation, and we can go back to the slides, and Brian, you can jump in here as well. I think what we were pointing out is some of the initial vendor views that have been presented in 3GPP are calling for the consolidation of the CUDU, basically eliminating the F1 interface. So that was more meant as a report out rather than a recommendation. So it's not meant to be supported. It was just meant for what we are seeing, some of the initial views that are coming from the vendor ecosystem around the consolidation.
This
Right.
is
That was. Yeah, no, that's exactly correct. That wasn't a recommendation that we were suggesting that interface be removed. It was an observation, again, readouts that we received. F1 interface, hasn't seen much implementation, for the opening that interface, but there are initiatives to open CUDU, and that will, progress forward. But yeah, if we go back to that slide, you can see it's more just as a readout rather than a recommendation.
Yeah, the reason I point out is because that's the position taken by one of the incumbent vendors versus others have taken a different position that needs to be kept open.
Sure.
That is correct. That is correct. Yes. So it's not consensus at this point. Absolutely correct.
Brian?
I think I got my question answered. It was around the integrated sensing and communication. It wasn't clear to me whether regulations precluded doing integrated sensing and communication, but I take it that it's the possibility that it might not be integrated that we need to look at. Anyway, I look forward to learning more about the use cases and whether it'll be UE devices or the radio access network or what exactly is doing the sensing and how it's going to roll out. Not really a question, just looking forward to more discussion there.
Yeah, definitely needs to be more, as this is one of the emerging technologies, and there's still a lot of open-ended questions for ISAC.
And just the first batch of the 60 studies, at least the recommendations that have been proposed in 3GPP are to focus on G-Node B base sensing, so kind of monostatic and kind of pushing, not necessarily mucking with the waveform, so to speak. So this is sort of just the initial ideas that have come out, but yes, that work needs to really mature a little bit, and we need to see some studies and results come out of it.
Adam?
So sort of two questions. One is you alluded to the fact that it's important to end up with a set of core standards as we go into 6G, as opposed to the expansive set of standards we ended up with in 5G. What do you see as the mechanism for doing that?
I think having more input into what the key areas of focus are and the standards that need to support those key areas. As we went into 5G, there was really a broad view on architecture, broad view on use cases, so that we got a significant amount of standards activity that took place. I think the focus as we move towards 6G is really focusing in on what the key use cases, the key enablers are going to be, and making sure that those standards are developed and we limit the number of options that go into the standards.
Okay. And so the last one was, I think just going through the whole presentation, there is a lot of, I would say, aspirational thinking of new technologies coming in, okay? What do you see, again, as sort of the mechanism that really does, I would say, a hard-nosed job of, I would say, creating the roadmaps to actually understand what is ready for prime time and what is not? Okay? And, examples I would give is, we have a lot of discussion on terahertz technologies, millimeter waves, things of that sort. We have things that go way back, cognitive radio, MIMO, things of that sort. And again, none of those have sort of come to full fruition and all the aspirations that we had. So what do you see as sort of the hard-nosed mechanism of saying, let's look at the basics and figure out really what are the time frames on which things will and will not be ready, and in creating those core standards, actually concentrating on those things that are really likely in the time frame for 6G?
Yeah, that's a great question, Adam. I think so. TBD, unfortunately, I think that would be the answer. It still remains to be seen because, June of this year was the first time the 6G study items were proposed in 3GPP. And frankly speaking, I think objectively, this is just a personal opinion, not representative of the TAC, but there was quite a strict notion of which study items were adopted, primarily looking at kind of a day zero view for 6G architecture. So I think we still need to continue to monitor which of those technologies are going to continue to be introduced in terms of different kind of study items, and then for us to be able to kind of parse them through a lens. I think it might be too early to kind of do away with certain technologies. I think we ought to still maintain and understand what the state of the art of development is, but we need to connect it back to as these release 2021 study items begin to mature in the next 18 to 24 months, and that will sort of give us a little bit of a perspective of where industry is leaning and where different interest groups around the different technology development is leaning. Brian, if you want to add anything.
Yeah, just to expand on that a little bit, if you look at the 3GPP SA1 use case study item report, the last I heard, it's probably somewhere around 300-400 pages in length, and there's a lot of use cases being defined in there. Certainly not all of them are going to make it into 3GPP 6G release 21, once the technical specifications are defined. But it is an iterative process. Let's take a broad look at all the potential use cases, and then narrow it down based on operator input. What is it going to bring the operator? Is an operator going to be able to monetize the use cases? Is it going to benefit the operator as far as reducing TCO? Or are there other benefits to users? Is it going to close the digital divide? Is it going to support sustainability? All those questions need to be answered for each of those use cases. And then you need to look at the technology side. Is the technology mature in order to realize those use cases? Things like ISAC, what's the technological maturity going to be in the 2030 timeframe? So that iterative process will take place, as we progress through the study phase within the standards organizations. And then finally, once the list gets narrowed down, and we'll move into the actual phase where the specifications are developed. But again, the number of specifications developed will probably exceed what will actually get deployed in the field. If we look historically back in standards, not all the standards that are developed are actually deployed. So it'll be an iterative process to get there, and then the actual deployments will be based on operators' needs, consumers' needs, as well as the overall societal needs for the different technologies.
Henning?
Yeah, I wanted to pick up on maybe a slightly indirect connection. So I'm obviously on the academic side. What I'm seeing is essentially a complete drying up of the talent pipeline where students no longer have really any interest in communications technology compared to AI, ML, natural language processing, you name it, just about any other field, robotics, you name it, and that. Uh, and, and this ties back to the previous point, is that this is partially because the technology is seen as so obscure, and it's like reinventing SS7, as in you have to learn lots of terribly boring stuff that isn't terribly intellectually interesting, and then participate in often legacy technologies. So I wonder if those are more from an industry perspective are seeing the same challenges, particularly in the US. This doesn't seem to be as common elsewhere, of a drying up of a talent pipeline, and is true both at the professorial level as well as the master's, doctoral, and undergraduate level, and how that's going to affect US competitiveness in particular, and whether a more simplified and more rapidly evolving infrastructure can do a little bit to make that field seem less daunting and less boring, to be quite frank.
So there are, I do concur with your concern, and also on the academic side, I do see some of those issues in terms of the pipeline development piece. I think I do feel encouraged by some of the auxiliary activities happening in terms of focus on the open architectures, focus on open source our technologies, and this is sort of the first generation where access to open interfaces and open source has led to a little bit of or quite a significant increase in being able to deploy and experiment with 5G technologies, pretty close to where the commercial network operators are deploying their networks and having an equal footing in standards based implementations, thanks to the open source and open interface based architectural kind of approaches. In addition, on the AI side, I think the work that's being done, obviously quite nascent right now, but with the AI RAN Alliance primarily, which is sort of bringing in some of the AI incumbents, moving them into the telco domain, and also seeing that interest from the legacy vendors is going to be quite interesting. So I do echo your concern, not necessarily giving a clear answer, but at least talking about some of the on ramps that have been developed and that will continue to be developed. But yeah, I do not think I have the kind of the silver bullet to solving this to solving this issue and making things much easier or implementable. Brian?
Yeah, no, I agree with everything that was said, and Henning, I agree with your assessment as well. Certainly we run the risk of U.S. and North American leadership because there are other regions of the world where they are focusing on technology development and have a good talent pipeline in this area. I think the thing, as Manu mentioned, is, what are those shiny new objects that 6G will have to offer, and looking for new areas of research, ISAC, satellite, those are two that immediately come to mind. But I think, we need to promote those areas, promote the need and the benefit, from national interests as well as global interests on what this technology has to offer.
Okay, any other questions? Okay, with that, so we've got the set of slides that include recommendations and advisements for the commission, as well as a white paper that's been circulated to all of the TAC members ahead of the meeting. So now, this being the final meeting of the charter, we'll call the vote. So we'll start with the ayes, and for folks in the room, if you could raise your hand, and for folks on Teams, if you could also use the hand raise feature. Okay. And then lower them, please. Are there any nays? Okay. Both the slides and the white paper pass, and we will be publishing those after the meeting. All right, thanks, everyone. Moving on to the...
Thank you very much.
Thank you, Brian and Manu. Moving on to the next presentation, we've got the Advanced Spectrum Sharing Working Group. Andy and Manisha, over to you.
Thanks, Martin, and thanks, Brian and Manu, for the 6G presentation. It's a good segue into ours. So the Advanced Spectrum Sharing Working Group has been co-chaired by Andrew, representing the Wireless Innovation Forum, and myself, representing the Wireless Institute at the University of Notre Dame. We had a very healthy participation this year, and what we are going to be reporting on is really activities that we've been involved in 2025, so January of 2025 to now. Very engaged discussions. We have 10 charter items that were given to us, and we assigned charter leads for each of them. And we will have the charter leads actually present the charter items, the discussion of the speakers that came in, what we agreed on, and the recommendations per charter item. In terms of work product, we have, of course, the slides and the recommendations in the slides. They also align with 4 white papers. We had 3 from 3 charter items and 1 which consolidated 2. So we've covered about 5 charter items with very detailed white papers that have also been circulated to the group ahead of time. Hopefully we will be able to get done in time for lunch. So this is the list of subject matter experts that we had. As you can see, we had really nice presentations from a wide variety of people, starting from academics, Professor Garcia talking about RF hardware, latest developments in academia on interference suppression. And under each presentation, you will see a related charter item. That was the focus of the presentation. However, most of the presentations were pretty general, and they provided a really nice background for what's going on in the area of technology development for spectrum sharing. And at this point, I will hand off to charter item 1 presenter. Is it okay if I click the slides? I think that'll probably work better. So I'll hand it over to Amit. Amit Mukhopadhyay started off with Nokia, ended up in Verizon, and he's going to present charter items 1 and 2. Take it away.
Thank you, Manisha. This particular charter item was actually in a fairly mature stage when we had our last meeting in December of last year. So I'm going to go fairly quickly and spend a couple of minutes on the recommendation at the end. So the question was, what will advanced sharing frameworks and architectures look like in the future? Now, we want to make sure that we are using the terminology properly. So I will just start with the framework question first, and then look at architecture separately, at least in our mind. We like to keep the concepts and definitions as clear as possible. When you talk about frameworks and emerging frameworks, what we see we're trying to draw inferences from what is happening in other parts of the world, which also may be applicable here, while we are also looking at different developments within the U.S. itself. The obvious reference that we see a bit different that is happening in Europe is spectrum sharing between licensed and unlicensed, in particular in upper 6 gigahertz, sharing between IMT and Wi-Fi networks. And the way the sharing is being conceived there is there are 2 or 3 different frameworks that are being taught. One is the simple indoor-outdoor framework, I should say. So IMT outdoors and Wi-Fi indoors, that's one of the proposals. The other one is IMT in urban areas and Wi-Fi in rural areas for the same upper 6 gigahertz. And as these 2 options were being evaluated, there was also a third option that came up where the lower part of the upper gigahertz spectrum will get priority by Wi-Fi, and the upper part will get priority by IMT in case there is a conflict. So there is another this variable spectrum priority, the third kind of framework came up. These are references that we would like to keep in mind while developing framework for the US or recommendation for FCC as well. The other thing that is also prevalent there is the concept of local licensing, in particular for the frequency range 3.8 to 4.2, that frequency range being very close to the altimeter frequency range 4.2 to 4.4 gigahertz. And again, in particular cases, we can also think of this becoming a potential additional framework for the US. In the context of US, we are very much familiar with the federal commercial sharing in CBRS, ambit, and so on and so forth. There are probably federal sharing frameworks as well in place. Commercial to commercial, we have not really seen in terms of sharing, but we can think of evolving those frameworks as well. Next slide, please. Okay. Now, if we talk about the emerging architectures and mechanisms that are enabling those framework, again, with respect to Europe, we're talking about a simple contention-based architecture that you're all familiar with in the context of Wi-Fi and other unlicensed spectrum applications. There's also a concept of inter-system signaling, so there could be a signaling imposed or between the Wi-Fi systems and IMT systems so that they know how to avoid each other. There is also another concept of uplink downlink split, meaning the upper 6 gigahertz, for example, is considered a TDD band typically. However, spectrum sharing becomes more difficult with the downlink transmission compared to the uplink transmission. If we can separate out uplink and downlink and allow the uplink on the lower part of the 6 gigahertz, that becomes easier perhaps to share with Wi-Fi. That's a concept that is being studied as well. And finally, there's a broadcast signal that basically informs the parties which part of the spectrum is being used and what to avoid and so on and so forth. Additionally, there are some other mechanisms also emerging, especially in the US. We can think of an enhanced coordination system like we had in CBRS or even ambit kind of environment. There are also thoughts about interference reporting, where one entity basically informs the other that a agreed upon threshold is being exceeded. There could be also transmitter identity so that it is clearly known which transmitter is causing the interference. There could be improvement in sensing, and finally, incumbent informing capability that could also play a role in providing the architecture and mechanisms for spectrum sharing. We have actually prepared a fairly detailed white paper. It has got a lot of details behind these thoughts here. And I'm going to just summarize the couple of recommendations. Next slide, please. So there are two main recommendations that you're talking about. One is we know most of the spectrum sharing situations in the US involves both the federal and commercial operations. So we need to have a multi-stakeholder group involving both the government agencies as well as commercial entities. But many cases, it is possible that some sensitive information has to be shared between the entities in order to make a proper in-depth technical evaluation of the sharing possibilities. And in many cases, the security clearance is becoming an issue. The recommendation is for this small group of technical experts whose judgment we do believe maybe we can make a special case for security clearance so that actual independent decisions can be made, objective decisions can be made. And also in the same context, we can think of some organizations that have a history of developing standards for federal commercial spectrum sharing. For example, Wind Forum or Wireless Innovation Forum, they can also play a critical role in this regard. Number two, there are SDOs and proprietary solution providers for the commercial side, and also mostly proprietary solution development for the federal equipment provider. These two parties have to be brought together and encouraged to develop solutions that will work for both the commercial side as well as the federal side. And when they develop the solution, what we needed to keep in mind is not just the technical side, but also the economic feasibility of the solutions. There are many solutions that are coming into play or being conceived on the technical side, but we cannot ignore the economic viability of the solutions either. That is pretty much what we have for Charter 1. I hope you got a chance to read through the report so that I'm not going to elaborate. Any questions, comments? If not, we'll move on to Charter 2.
Good, Marvin.
It would seem to me that organizations, certain federal users of spectrum, have an incentive not to encourage the development of new uses on a shared basis because it precludes future things that they might not do with the spectrum. You could develop shared uses that are compatible with existing uses, but there's an opportunity cost of allowing new uses that will foreclose other changes in the future. And how does this get reconciled?
So our idea is whenever we are talking about future use cases, we do take into account the possibility of spectrum sharing, if that is indeed a shared spectrum. And in reality, in many cases we have seen it is actually beneficial to have the capability of sharing the spectrum. We have had this discussion, for example, in the context of 3.1 to 3.45. Yes, the radars want the full protection because they have to do their duties. But if they can develop the capabilities of being able to discriminate the objects at the right granularity, that makes them more battlefield ready than if they were operating in an isolated environment. So there is a benefit of developing the capability, and that's what we would like to encourage.
I see no other questions. Go ahead.
Okay. Now we're moving on to Charter Item 2. There are two questions here. How will spectrum sharing models adapt and evolve to meet growing demand for spectrum access among various services to support multiple purposes? And the second question is, how can the interplay between terrestrial and satellite services be complemented in sharing models to promote more efficient spectrum use? Now, if you look at these two questions, you may think that these could be standalone questions by themselves, but because they were put together, we thought there is a significance in tying them together and creating not really a report, but at least a group of slides that will help answer these questions. I would like to thank Michelle Thompson, who carried along during my transition period. So thank you very much, Michelle. Next slide, please. Again, we like to make sure that we have the right terminology. Often, people confuse sharing models, sharing mechanisms, etc., but we just wanted to put it out in the slide. And I will clearly say this is much of this material has been adopted from the John Chapin presentation that Manisha shared earlier. The basic concept of what a sharing model is. The model is basically a definition of spectrum sharing usage rights, and what are the protection criteria is clearly spelled out. And finally, the provision of spectrum access opportunities. When can one system actually access the spectrum? And when you talk about spectrum sharing mechanism, it refers to, it is really an analyzer of the relevant data. It makes the decision about who gets spectrum access and an implementation of the decisions, all these things together. Now, when you look at these two, even though I'm trying to make sure that we understand the concepts, they don't evolve in isolation, right? Spectrum sharing models are dependent upon the different spectrum sharing mechanisms. So as the mechanisms evolve, sharing models can also evolve. It can be more sophisticated as we go forward. Next slide, please. So here is an example of how this spectrum sharing models are evolving, and that can actually lead to different spectrum sharing models. We saw different measurements on the CBRS over multiple years has actually resulted in smaller DPA neighborhoods, thereby allowing much bigger population to use this spectrum without interruptions. Similarly, in ambit, we have seen measurements over a longer period of time and analysis. Many sites were originally denied because of possible interference, but they came back. But here, basically what I'm trying to paint the picture is measurements, analysis are leading to new spectrum models. And what we're talking about is two types of sharing models. One we're referring to as non-cooperative sharing models. In this case, the two parties sharing the spectrum do not have a common interest. They are competing against each other, but regulators get involved in compliance. It's some sort of an enforcement of the compliance. Another one, which would be cooperative sensing model, where the two parties have a mutual interest in sharing. And this because they have mutually beneficial arrangement, and they could have a closed loop system so that there is a active mechanism of being able to share the spectrum that benefits both parties. Example of one, non-cooperative sharing, could be basically the hybrid sharing example that I was talking about being assessed in Europe between IMT and Wi-Fi. They are, in some sense, competing technologies. So there may or may not be incentive to share. However, it can be with a proper regulatory framework, the sharing can be encouraged or enforced with the right regulatory framework. On the other hand, if we look at the supplementary coverage of space that we have in the US, we can think of both the terrestrial network and the non-terrestrial network have a common interest of enhancing their revenues. So the interest for them is how do we best do the sharing. Let's go to the next slide, and we can have a little closer look at the two concepts, non-cooperative and cooperative sharing. As I was mentioning before, in non-cooperative sharing, the concept we talked about the hybrid sharing. So one instance of this hybrid sharing is IMT outdoors and Wi-Fi indoors, and the compliance is monitored, right? The justification for this arrangement was it was not clear for Ofcom that originally came up with this idea whether it's more important for Wi-Fi or IMT. So they basically allowed the industry to figure out how to share the spectrum, right? And the idea there was that take advantage of in-building penetration loss, especially in the higher spectrum, in the 6 GHz band, in particular because of this newer buildings with exterior loss, penetration loss, whether they can leverage that. The challenge that still remains is many of the cases, there are leakage from both from outside to inside and inside to outside. How do we manage that interference and come up with a proper framework? On the cooperative side, there is possible evolution of SCS as we talked before. The idea is how do we adjust the coverage of terrestrial and non-terrestrial networks. Currently, the practice is you having the same spectrum, often to share it between terrestrial and non-terrestrial. The reason being, then we can use the same device for both coverages. The issue becomes, or the fundamental question becomes, at the edge of the network where the terrestrial network is challenged, how do we manage the interference between the terrestrial and non-terrestrial network? So, and one of the things that came to mind is this is very similar to what you have seen in heterogeneous networks. The macro cell is basically under the macro cell umbrella. There are small cells, and we manage their intercell interference, or EICIs, enhanced intercell interference coordination. And we can think of similar mechanism provided there is a closed loop mechanism between the terrestrial and the non-terrestrial networks, and this is something that needs to be done. We'll go to the recommendations. Next slide, please. So there are four recommendations in this case. One main thing is spectrum sensing. It becomes a very important thing, and we should encourage the development of efficient spectrum sharing capabilities. We're also thinking about developing frameworks for non-cooperative sharing, because cooperative sharing, the parties will work it out among themselves, but for non-cooperative sharing is particularly, especially for federal and non-federal. Now, sharing between terrestrial and non-terrestrial is extremely challenging. We may think of sharing between the uplink of non-terrestrial with the terrestrial system, but downlink is very challenging. And further, last but not least, developing technologies that apply the HETNET principles, as I mentioned before, to our spectrum sharing between terrestrial and non-terrestrial services. That's all I have. Any questions?
Sure, you go ahead. Press the red button, the right button, and it'll turn red. Yes.
Okay. Thanks. So, question on sharing, and in the context of CBRS, where you leverage a SaaS database to mediate between different parties. I was just wondering if there's a role for AI to make this whole process more efficient, and you highlighted some challenges associated with spectrum sharing with NTN and other terrestrial networks. Would that be a opportunity to explore?
It is very much in the works. Absolutely, very much in the works.
And how would you I'm just trying to understand, what is the mechanics of, say, suppose you use a LLM model to how do you suppose it would work?
Basic AI technology is not just Gen AI, but AI technologies are being used even today as techniques are being developed. There is certainly it is in practice being done today. We can talk a little bit offline if you want. Thanks.
Just to add to that, I think Adam will probably talk a little bit about AI and spectrum sharing, so that a lot of the AI aspects have been discussed in the AI ML working group. But clearly, AI can be used and is being used actually even today to improve many of these spectrum sharing mechanisms.
We've got one hand online. Henning?
Yeah, a related question that others might be able to answer. Enforcement is mentioned in one of the slides, and I wonder if there has been any effort to quantify, say for CBRS or other reasonably large-scale shared spectrum deployments, as to whether there have been enforcement challenges or whether there's been a perception of abuse of, say, indoor-outdoor or other power limits and so on in practical deployment.
I think Andy can give the first hand.
Yeah, I mean, this is Andy Clegg, Henning. So speaking from experience up through earlier this year, there have been a few enforcement issues in CBRS, not many. I think over the 5-year history of CBRS at that point, there were, I think, 4 or 5 inquiries from the commission with the SAS administrators due to complaints, and I believe there was only 1 actual enforcement notice issued with regard to CBRS. So there really hasn't been a big enforcement challenge in CBRS. Now, that doesn't mean there hasn't been interference. Most of the interference complaints that we dealt with were GAA to GAA operators. There's really, in the FCC rules, there's no direction regarding the ability for a SAS to mitigate GAA to GAA interference. In other words, if you deploy a GAA device, somebody is absolutely free to deploy a GAA device on the exact same frequency right across the street from you, and a SAS cannot keep that from happening. There's no mechanism to allow that. But that's not really an enforcement issue. That's just the way CBRS is built. But overall, there have been very few enforcement issues that have come up in CBRS, so it's been pretty quiescent in that way. And I should also throw in, because I always like to say this, there has been no reported case of interference from CBRS into the incumbent during the history, for the first 5 years of history of CBRS. So it's amazingly well behaved, I think, and I think it's a good indicator for future shared spectrum bands.
Thank you.
Ricken.
Well, speaking of 5-year anniversary, I just want to remind another 5-year anniversary, and that is 6 gigahertz allocation by the FCC. So the question here, Amit, is that I know it was an attempt to define terminology, and that is models versus mechanism and so forth. But kind of curious that for the non-cooperative example you chose, and I know I was part of the working group as well, but the question here is that we are showing the IMT versus IMT and RLN that is not being considered in the US. We are all set here thanks to FCC. All full 1200 is assigned for Wi-Fi. But if we have to consider a similar sharing in the US, which other band you think is possible outside of 6 gigahertz? 6 gigahertz is not on the table. So any other band that could leverage that platform?
It's a purely my guess, right? I can think of even the lower part of the 7 gigahertz that you're talking about, say 7125 to 7400, that could be a possibility, because I know both the Wi-Fi is trying to get the lower 125 megahertz and IMD. Again, this is purely my guess, nothing more than
Okay.
that.
All right, yep, thank you.
I don't see any more questions. Back to you.
Thanks, Amit. So we'll hand off to Dave Gurney, who will take us to spectrum sharing. Can we get the slides back? Can you get the slides back?
Okay, charter item 3.
One sec, we're
Sure.
still waiting for the slides to come up.
I can see them. I think we need to see them on the monitor in the room.
Okay.
There we go.
Okay.
Okay.
All right, charter item 3, the commission asked, in what ways can the FCC optimize its propagation models to reflect less conservative and more realistic assumptions and support more intensive sharing while still protecting against harmful interference? Then the second question was, are there specific bands where improved propagation models offer a pathway to liberalize performance capabilities beyond what the FCC permits today? We completed a report providing an overview of several different propagation models, popular propagation models in the low, mid, and high bands, and more importantly, their limitations, because pretty much every propagation model has limitations, which we can touch on later. We also did give an overview of certain bands that could be considered for more intensive sharing. That's still an open question going forward, so we didn't have specific recommendations on bands, although we did have recommendations on propagation model improvements. Clutter, what we see in this study is that clutter modeling is really crucial for improved propagation modeling accuracy, among other items. And one good example of that is the ITM irregular terrain model that does not consider clutter today, although it's a very popular model and very useful in certain situations. It doesn't consider detailed clutter. There are other models that don't consider detailed terrain, like HADA and related models. So every propagation model has its limitations. But one thing we have seen so far in shared spectrum bands, like the 3.55 gigahertz band, is that there have been significant improvements over the last year that have been implemented that really improve sharing in those bands. The prime example of that, as I mentioned, is in the CBRS band that incorporated P2108 clutter models, median propagation modes, system loading, and transmit duty cycles, which resulted in very significant additional propagation losses, which in turn improves the sharing in the band, opens up the band to millions of more users. So that's very beneficial, while still protecting incumbents from interference. The 6 gigahertz band, as another example, already incorporates P2108 and P452 clutter models. Those are important going forward as well. In terms of studies in the band, there's several groups performing studies. One of them is NTIA-ITS, which has been looking at improved propagation modeling and clutter modeling in the mid-bands. And that was the subject of NTIA-ITS workshops, both in 24 and coming up in 25. In terms of clutter modeling itself, National Land Cover Database is a very popular database that's widely used. Classifies clutter into several categories in 1 arcsecond resolution. There are improvements that can be made on that database, though. You could use AI or other techniques to further classify those tiles and perhaps more accurately classify those tiles, especially if you pull in things like LiDAR data and you start looking at like digital surface modeling to get actual clutter heights, which are becoming more and more realistic these days to implement. So we strongly suggest that we continue to push these types of improvements going forward. And we made some of those recommendations in the white paper, but specifically to go over these, we do encourage the Commission to continue to refine the effectiveness of propagation modeling used in the estimation of signal levels and harmful interference in spectrum sharing bands by incorporating some of these more realistic and advanced techniques, modeling techniques. We also encourage the Commission to continue to incorporate appropriate clutter modeling, including the appropriate risk assessments to increase the accuracy of propagation models and evaluating the coexistence of communication services and spectrum sharing bands. And when we talk about risk assessments, what we're really talking about is, hey, what are the services that you're protecting? Are they mission critical services? Are they DoD or life safety, public safety type services? Those obviously have to have a higher bar in terms of protection than, say, unlicensed or other less critical types of services. We also consider the commission to encourage all parties to continue to prove out the reliability of the propagation models, the reliability and accuracy of the propagation models through real-world measurement studies. And as I mentioned, there's several of those going on as well, but that's an important piece to verify that the propagation models remain accurate over time. So that's the extent of our recommendations on propagation modeling. If there's any questions, I'll be happy to answer. Okay, thank you.
Thank you, Dave. And there'll be opportunity to ask questions at the end on all of these charter items. So now I'd like to hand over charter item 4 to Tom Savanavori, who I believe is going to be presenting this charter item virtually. Tom, are you there?
I'm here.
Okay, please take it away.
Okay, good afternoon, everybody, and thank you. I'll be covering a little bit on Charter Item 4, which was really around questions to better facilitate spectrum repurposing efforts, both looking at both intra-band and interband issues, how incumbent services can be better informed about the nature of adjacent spectrum environments, and what steps and processes could be used with regard to receiver bandwidths. So I was the lead for this overall. Roger Nichols was originally part of the group. He's since retired, so I'll be presenting on behalf of the sub-working group in the group. Overall, I wanted to say that we looked at several case studies in looking at spectrum repurposing efforts, most notably the C-band effort that was done several years ago, in which the satellite community agreed to sort of retune and repack their services into the upper part of the C-band, and which allowed for essentially clearing of the C-band in one of the most successful auctions ever in history that the FCC conducted. But there were very good multi-stakeholder group engagements and lessons learned from that particular initiative, which was a major initiative. We also looked at 6 gigahertz, making that 1200 megahertz of 6 gigahertz available, and then continuing to work with incumbents utilizing concepts such as the AFC for database coordination in order to make sure there was minimizing the opportunities for interference. And then more recently, we've been monitoring the efforts in the UK with Ofcom and in Europe with CEPT of the 6 gigahertz hybrid sharing. There are really 2 different concepts that are being evaluated there. Amit mentioned them, both the indoor-outdoor, sort of indoor using, allowing for Wi-Fi, and then outdoor for licensed spectrum. And then there's another model which is being looked at for more of a spectrum split. So we have looked at those and are continuing to monitor those and make recommendations for the FCC to continue to monitor that for potential use in the U.S. I'll also note that back in December when we last met, we did make a recommendation to look at the upper C-band, which is the spectrum between 3.98 and 4.2 gigahertz, just below the altimeter band. And since then, the FCC has taken up that in a proceeding. So that's good to know that they are looking at the efforts that we recommended previously back last year. So again, our recommendations are we should consider lessons learned from that C-band spectrum repurposing and how to work with both the aviation community and the FAA. We should look at considered additional opportunities for spectrum sharing with incumbents using various geographical and database-driven protections, similar to the AFC, wherever it's appropriate. And the FCC should monitor the progress of the Ofcom and CPT investigations on the Wi-Fi and licensed spectrum sharing coexistence, and consider implications for what we might be able to do in the US, either in that band or in other bands. So those are our recommendations, and we've documented this into a white paper, which has been circulated in advance for your review. So I'll pause for any questions or maybe at this time. Okay, thank you.
Okay, the next charter item 5, I will be presenting. Myself and Dale Hatfield from UC Boulder, who are the leads for this. There were a number of questions that were posed to us in this charter item, all related to what can we do in receiver side. So much of the discussion on spectrum sharing tends to center around what you can do with transmit rules, what conditions can you put on transmitters. So this question is specific to receivers, which is actually quite pertinent because interference occurs at the receiver, not at the transmitter. So much as we might try to regulate transmitters, we have to take into account what can happen in receivers. So the 5 questions: what is the current state of the art in receiver technology? State of the art in active antenna array and filter technologies that can be utilized to mitigate potential harmful interference? How can advanced antenna systems help reduce both intersystem and intrasystem interference and enhance intrasystem performance using beam and null steering? What are the cost-benefit trade-offs in utilizing the current filter technologies or advanced antenna systems? And are there specific bands where improved receiver technologies offer significantly improved coexistence beyond what is permitted today? So on this particular charter item, we invited a lot of subject matter experts to come and talk about receivers. Receiver technologies are usually very closely held, and it is sometimes difficult to have representatives come and talk about what they're actually doing in receivers. But nevertheless, I think we had heard from some really interesting projects and efforts in academia, industry, and other government agencies like DARPA on what they're doing to push the state of the art in RF filter antenna array technologies. So the work product out of this group is really a set of recommendations listed on the next slide. We hope that if the FCC TAC were to continue into another session, and this is a continuing topic of interest, we'll be able to compile what we heard into a more detailed report. So we basically have 2 main recommendations. One of the things we learned as a group is that there are considerable advances being made in RF filter technologies that could enable higher power handling, better out-of-band interference performance, and lower insertion loss. So these are very practical matters which you have to take into account when you're designing a better filter. But there's a lot of research being done on newer materials and newer concepts. We heard from a company from both DARPA and another company about new BAW filters, X-BAW filters. And these are already delivering performance.
Check this out. Okay.
Yeah, I'm on that. On spectrum sharing. And so the recommendation at this point for the FCC, because the FCC doesn't yet regulate receivers, is to actually follow these developments pretty closely, because in the future, as new spectrum regulations are being developed for new bands, we definitely think that improved receiver performance can enhance spectrum sharing. We also had a few presentations on antenna arrays, and it's pretty clear that active antenna arrays, phased arrays, do offer improved interference rejection capabilities. Whether you're using beam or null steering, you can do these things. So the hardware capability for doing this is fairly mature. But the algorithms that can actually detect, where the interference is coming from and how do you very quickly place a null in the direction of an oncoming radar, that's still a work in progress. So there is a lot of developments being made, and AI and other techniques are being used to develop these approaches. But this is still challenging, and there are many other efforts within the government to mature these technologies. And again, the broad recommendation here is that given the state of development in active antenna technologies, not just for improving the native system performance, so 5G and possibly 6G will use active antennas very well to improve their own performance, but how do you leverage these additional degrees of freedom to do better things with interference cancellation? There is a cost associated with it, especially if you're trying to do some of these interference, adaptive antenna, or even high, better RF filter technologies in handsets. There is a cost component that has to be considered. But where appropriate and cost-effective, the FCC should definitely encourage more use of advanced receiver technologies so that we can do better spectrum sharing. So that's it for this charter item 5, and I'm happy to take any questions. Any questions online? No? Okay, so I will now hand off to Andy to take us through the rest of the charter items and conclude the presentation.
Okay, thanks, Manisha. So we will move on to the next charter item, and actually we combined 2 of our 10 charter items. We combined charter item 6 with, yes, got it, charter item 8. So we took 6 and 8 together because they were sufficiently related. The lead on this was Jason Jackson from Kyndryl, who did actually an amazing amount of work on these charter items. Unfortunately, he was not able to attend this meeting today. So in his stead, another contributor to our working group, Michael Cataletto, will take us through these 2 charter items.
Thanks, Andy. So the 2 charter items that we're covering at this point are item 6 and item 8. So item 8 focused on what candidate bands and services can coexist with low power indoor-only operations such as factory automation, and what are the sharing mechanisms to consider. So this gets right to what Rikan was asking a few minutes ago to Amit. And then item 8, what role should sensors play in informing spectrum use and in supplementing spectrum sharing databases? The output of all of our discussions was development of white paper with the recommendations for these 2 chart items, and there were 6 core recommendations that we addressed in this white paper. So initially, we took a look at the core impetus for the initial charter question with item 6, which prompted the first recommendation. So our first recommendation was a shift in focus from indoor and outdoor use to contained and uncontained use. Specifically, we're recommending a focus on RF containment as an enabling method for spectrum sharing, particularly in environments where RF signals can be naturally or artificially confined. For example, in a remote location such as a mine, where containment is naturally achieved through a geographic or physical isolation. These areas should be allowed a little bit more leniency with regards to transmission power and frequency use because the risk of interference is minimal with other networks. On the other hand, in more populated areas like urban areas, the potential for interference is higher, so stricter containment measures are required. For example, in a smart factory in a metropolitan area, we would promote the use of RF shielding to ensure that its internal communications don't interfere with outdoor systems like cellular and microwave towers. Using proper containment, the factory's low-power IoT systems could share spectrum with the surrounding networks without risk of interference. Along the same lines, we've included in the white paper recommendations on defining what a contained environment is and how to set measurable standards for RF containment. Third, we continue to encourage industry collaboration with regards to standard practices, specifically with regards to the use of automated frequency coordination. A warehouse automation system can communicate with the SAS to identify the best available frequencies for its operation, ensuring safe coexistence with nearby outdoor networks, very similar to what's already going on with CBRS and 6 gigahertz. Fourth, we want to continue to promote leveraging technologies like dynamic spectrum access and RF shielding. A smart factory could use dynamic spectrum access to automatically adjust its communication systems based on real-time spectrum availability. If a frequency band becomes crowded, the factory systems could switch easily to a less congested band, ensuring efficient spectrum use. Fifth, continue to study methods for enforcement and compliance. This includes considering the use of sensing algorithms, including RAN-based sensing, to monitor and as well as enforce containment. Lastly, we've got a number of potential bands that we were considering for this use. First, as Amit said, lower 7, 11, 12, 18 gigahertz as well as above 100 gigahertz. Really anything that propagation through physical barriers is difficult. Originally, we had 37 to 37.6 in the white paper, but we've since removed it due to its inclusion in the latest notice of proposed rulemaking, which was released a few months ago. And all these white papers have been shared, and Martin has sent those out. And thanks again for all the TAC members who helped with the development of the white paper and the feedback on it as well.
Yep, thanks, Michael. Thanks very much. Are there any questions regarding these charter items? Nope, I'm not seeing anything. I think lunch is getting closer, so that's a good sign. So we will move on to charter item 7. The specific charter item is what are the sharing mechanisms to consider among various services above 95 gigahertz, including passive services. This charter item was led by Dr. Michael Marcus from Northeastern University, who's here. Raised his hand in the back of the room. So if you want to go to the next slide. So we actually dedicated 2 sessions to discussing this particular item, and Mike actually drafted a fair amount of material related to considerations about sharing bands above 95 gigahertz. Including considerations of propagation and other factors. However, we weren't, during the course of the session that we had, we weren't able to come to consensus with regard to the details of sharing of spectrum above 95 gigahertz. There's a lot to discuss, and we weren't able to get through it all. So, this may be something we take up in another session if that's a renewed charter item that the FCC gives us. But we were not able to come up with consensus regarding sharing of 95 gigahertz. And the bottom line had to do with the existence of a significant existence of passive services in 95 gigahertz and how to properly protect them. So, we think it's doable. It's just we couldn't come to conclusion on the details of how that would all work. So that was the result of Charter Item 7. I guess to the extent that anybody would have questions about that, we'd be happy to entertain them. Nope, okay, not seeing any. So thanks, Manisha. We'll go to Charter Item 9, remembering that we had combined 8 with 6. So 8 was previously addressed by Michael. Charter Item 9 was led by Rob Alderfer from Charter. I believe Rob is online. Okay, great. So Rob is online. So Rob, do you want to take it?
Sure, yeah, thanks, Andy. So Charter Item 9 focused on the trade-offs and complements between efficient spectrum use and sustainability and energy efficiency. And so our readout here in our work product is largely focused on the observations that we've come to as a group. We don't have specific recommendations for the commission. And we did cover a number of these constructs at the last meeting, so I'll just summarize them briefly here. If we can go to the next slide, Andy. As we do that, from a network architecture and RF design perspective, we often talk about signal dispersion or propagation loss. And another way to think of that is actually energy loss as well. And so that tends to happen over distance and through clutter. And so minimizing transmission distance and clutter is actually a way to become more efficient in the architecture of mobile networks. And so you take that fundamental observation alongside the notion that traffic demand tends to be very localized as well. It points to an obvious opportunity in terms of driving greater energy efficiency in wireless networks, just to drive greater density through small cells, lower power nodes in the network, and really to serve local traffic with local networks. And so the tie into spectrum sharing, I think, is relevant here as well in terms of lower power, more energy efficient networks, also opening up potentially more opportunities for spectrum sharing in the geographic domain with incumbent spectrum users as well. And so I think these conclusions apply really across network technologies and are really more around architecture, so mobile and Wi-Fi. We also have a few related considerations more broadly on the next slide. As we think about more than just network architecture, there are a number of energy efficiency developments that are in development or on the horizon. Some of them were discussed in the readout from the 6G group. For example, the utilization of sleep modes, which is sort of colloquial term, and captures some of the constructs that are happening in 3GPP 6G standards development, as well as in Wi-Fi and fixed networks, to essentially become more intelligent in network operations through calibrating network activity to traffic demand. So recognizing that there are diurnal and other predictable patterns to network traffic, that opens up an opportunity to become more efficient in how networks are operated by turning up or down carriers that in a manner that's responsive to demand. So that's one example of other technologies beyond network architecture that are driving greater energy efficiency in wireless networks. And the result of that, collectively over time, I think we've seen a trend to really decouple energy use from performance gains on wireless networks. And so there hasn't been a linear increase in energy use as performance has grown. And I think we can expect that trend to continue. And of course, at the highest level, communications networks, wireless networks enable a range of other energy efficient use cases in other economic sectors, manufacturing, transportation, of course, and myself and a number of my colleagues are taking full advantage of that today by participating remotely and saving some carbon emissions as a function of travel. So those are some of the observations we had around energy efficiency and spectrum sharing, and about to take any questions or discussions around that.
Thank you, Rob. Any questions? We do have one. Mark?
As you're okay. So as you're talking about energy efficiency, you're talking about idle times and being able to put the network down. As you're doing all that, it's just really great. But the problem is, if we still continue using carrier grade NATs and continue to running dual stack with IPv4, we're still running constantly network ARP traffic from the devices that are no longer needed. We're doubling the total amount of basically traffic that's on the network. And as we're moving forward to try and get these networks more efficient, we really need to follow the same that OMB is doing with the federal government and end the use of IPv4. And that would save us dramatically. Just getting rid of the carrier grade NATs and getting rid of the IPv4, we'd save almost 30% of the energy utilization and get back over 50% of the spectrum utilization. And we're already doing that in the government now. We might as well just push that through, because there's no reason to come up with a super phenomenal network that we're being able to monitor stuff if we're still running an old protocols through that are completely inefficient. Yeah, so that was it.
Rob, any
No, I didn't hear a question in there, but I'll just note that these constructs do often have trade-offs, and I think a few of them were raised in that comment.
Okay, Amit.
Just wanted to comment that about the this decoupling energy use from performance gains. The fact of the matter is, as we go into higher frequencies, we're getting into more complicated MIMO configurations and beamforming, and their computations become much more energy dependent. So you can't really fully decouple those things. If you take in the big picture, deployment costs, the actual computational costs, everything comes into play. That's just a comment. Thank you.
Yeah, and I think the statement here is really referring at the highest level, network level performance and consumption as a function of the various components of a network. And so as we move to higher frequency utilization in networks, the mix may change, right? So how that manifests may differ from what we've seen in recent history. But I think it is pretty impressive that we've been able to see significant performance gains across wireless and broadband networks, for that matter, without a linear increase in energy use.
Okay, thanks, Rob, and thanks, Mark and Amit, for the questions.
Andy, there's
Yes.
one online. Henning
Yes.
raised his hand.
Thank you. I was curious, given the trade-offs, particularly on the spectrum side between unlicensed and licensed use, and as to whether there has been an attempt made, particularly for some of the high-intensity applications like AR/VR that were mentioned early on, to compare energy usage across these different modalities as well, given that there's been much less emphasis on the IMT side on the highest frequency, closest distance type spectrum, and much more on more traditional macro cell to have a much longer propagation distances than they might have been anticipated a few years ago.
Yeah, Henning, so we didn't look at specific use cases, but I think your comment does get to the observations we have around network architectures, and what you're raising is a great example of a use case that is highly localized. People tend to use AR, VR in a stationary manner, and serving that sort of traffic with local networks, whether it's Wi-Fi or a mobile small cell, is likely to be more energy efficient than doing so with a macro cell.
Thank you.
Okay, if there are no other questions, we'll move on to the last charter item. This is charter item 10. The leads on this were Michael Cataletto and myself. So the specific items under charter item 10 are what methods can support the commission in identifying spectrum bands that have the most potential and flexibility for sharing and repurposing? What are the candidate bands and which bands should be prioritized? How should those bands be combined or separated for federal and/or non-federal uses? And what are the optimal coordination processes between stakeholders to better support implementation and consideration of these methods? So when I looked at these charter items, I think they could fill 2 or 3 years worth of TAC discussion. So we did have a fair amount of discussion on the general concepts here. We don't have any specific recommendations. Perhaps it's something we can follow up on in a future session of the TAC, but I will discuss those considerations here. I am skipping one slide on purpose because I realize it's fairly repetitive with what's on the following 2 slides, so I'll go directly to the first slide. So we had general discussions of what are the characteristics of services, communication services that make them potentially suitable for sharing. So we came up with several characteristics here. One of the primary things is if the receivers in the primary system that have to be protected are sparsely deployed in geography, frequency, and/or time. So examples of this are radio astronomy, where you have very few radio astronomy observatories, and they tend to be geographically isolated. Same thing for some satellite receive-only Earth stations. You only really need to protect the satellite downlink signal in the immediate vicinity of the Earth stations and at their frequencies. And then, kind of the most common example would be the DoD radar in the CBRS bands. They are operated relatively few sites, a few ships that are out in the coastal areas, and then a few radar sites that are sparsely located geographically within the continental United States. So, with those characteristics, you're going to make the band or that particular service more likely to be able to be shared. Another characteristic is if the primary use of a particular service is not critical, so not safety of life. If it is safety of life or it is critical, we don't think it necessarily precludes spectrum sharing if some of the other characteristics are met, but it does make it an additional consideration for how you would share those bands. So, as an example, the medical body area networks that operate in 2360 to 2400 megahertz band, those are obviously, it's a critical service, but even those are shared with other operations. For example, it's shared with the planetary radar at the, what used to be the Arecibo Observatory down in Puerto Rico. But, it is a factor that you have to take into account. If the primary systems are robust against interference, so if you think about the 6 gigahertz band and the sharing with the unlicensed devices using an AFC, those particular systems have used the point-to-point links that are in 6 gigahertz that have to be protected, use highly directional antennas, and that can facilitate spectrum sharing as long as you stay out of the main beam of those particular systems. So that is conducive to spectrum sharing. And then if the secondary systems have adaptable characteristics, again, highly directional beams, but the use of beamforming and nulling, strong transmit filtering, et cetera, that make them more compatible with the incumbent systems. It's also a consideration of the secondary user themselves are adaptable and interruptible. So one of the things that came up in the CBRS band was that when the secondary users, the CBRS users, provided, for example, home internet service using CBRS GAA or whatever, and then a Navy ship would come along and turn its radar on for hours at a time, taking down the home internet service for the users that were relying on CBRS. It apparently for the first time dawned on the CBRS operators that this was not an optimal situation. You really don't want to take people's home internet service down for hours at a time. And it's one of the considerations that led to some of the relaxation in the size of the neighborhoods around DPAs. It wasn't that the Navy relented, it was that we realized that there were so few cases of actual interference or no cases of interference to the incumbent that a relaxation was in order. We were probably overprotecting. So it reduced the amount of interruptions to the secondary user by reducing the size of the DPA neighborhoods. But it is a consideration, and it made us realize that the secondary user themselves needs to be adaptable. If you're using it only for a supplementary service rather than your primary service, it makes it a lot more possible for you to share the band under those considerations. And then finally, two more things. If propagation is constrained so that you operate only indoors, so the primary or the secondary user only operates indoors, and the complementary secondary or primary service only operates outdoors, it makes it easier to share. We're seeing that in the UK in the Ofcom experiment. And also in higher frequency bands where clutter plays a major impact and signals just don't travel as far, it is going to also make it more likely to be able to share. And then better receiver characteristics if you're less prone to overload or other types of nonlinear response to signals that are sharing the same band that you're in. there might be some virtue in regulating receiver performance in shared spectrum bands. And in fact, in CBRS, there actually are some requirements on receivers in the CBRS band that they have to tolerate certain levels of interference. That's another thing that could make a service more likely to be able to share a spectrum band. And then finally, there is the characteristics of bands as opposed to services that can make them potentially suitable for sharing. Again, higher frequencies where propagation doesn't go quite as far might be more amenable to sharing under certain circumstances. Has the band been identified for particular uses through the international process? So, for example, if the ITU has designated a band for IMT, or 3GPP has standardized a band for 5G or 6G, that could be an indicator that we should look more closely at that band for the potential for sharing between mobile broadband, for example, and incumbent systems. And there are a lot of there's a lot of considerations of technical perspective versus economic considerations, because there are ways to share bands if you're willing to spend a lot of money to do it. So you've got to look at the trade-off between what the technical considerations are versus economic reality. Those are the those are the considerations that we came up with regard to Charter Item 10. Be glad to take any questions on that before we continue on. Nope. No questions, good. So we did have a couple of thoughts, based on the discussion we just had.
Andy,
Yes,
sorry to interrupt.
online.
Sorry, I was a little late.
Yeah.
To get to a button. So one of the questions that I don't recall being discussed all that much is many of these considerations would be that you helpfully enumerated would be pretty much universal as an independent of geography, as in Europe would have the same considerations as, say, China. Have you seen, based on your international perspectives, that some other regions have been more aggressive than the U.S.? My perception is that it's actually the opposite, that the U.S. has been has been a leader in scaling up, particularly sharing, given the CBRS experience that you refer to repeatedly. So I'm curious if there are other models that the U.S. has not tried of shared spectrum use that would be interesting to look at, both from an economic and from a technology perspective.
So no, like you alluded to, the other countries have actually been coming to us asking to learn about our experiences with CBRS, because CBRS is the most dynamic and widespread spectrum sharing experiment that anybody has done around the world that we're aware of. And so people have been coming to us to learn some lessons. There have been instances of things like in the UK with the local licensing and things that, we don't really quite do things like that here. So maybe there are some lessons learned there, but they have a different situation in the bands that they're doing local licensing than we do. There's different licensing regimes and there's different considerations. So it's not necessarily something that we could adopt here. But to your question, Henning, so far we've been sort of looked at as the leader in aggressive and dynamic forms of spectrum sharing, and nobody else has really done anything quite like that. Canada is doing some 6 gigahertz AFC type things, and some other countries are as well. But again, as far as large scale and dynamic, we seem to be the leader in that, for better or worse.
If I just add to that, Henning, I think as Andy said, I think the rest of the world has learned from the U.S. The one thing that the U.K. is doing, and maybe the EU will follow, is the upper 6 gigahertz. But we are not going to revisit the upper 6 gigahertz necessarily in this country, but there may be lessons learned from what they are doing with spectrum sharing between. It's actually pulling together a bunch of threads: indoor, outdoor, Wi-Fi, IMT, different applications. So that'll be an interesting thing to follow up on.
Great. Okay, if no other questions, just a couple of other items. So we do have some thoughts on future charter items. I think it's worthwhile to consider continuing to study the spectrum sharing above 95 gigahertz. As Chairman Carr mentioned, earlier, he likes that the TAC addresses far future type things, and I can tell you that, significant spectrum sharing above 95 gigahertz, widespread spectrum sharing is probably definitely a future item. It's not happening today. Technology above 95 gigahertz is very expensive and very power inefficient, and a number of other things that means that we haven't quite gotten above 95 gigahertz yet, but that is kind of a far future thing that's probably worth continuing to look at. And then Dale Hatfield and others within the group brought some overarching considerations about the role of enforcement and security in shared spectrum. And in fact, kind of late in the process, Dale provided us with a number of significant thoughts in this area. And in fact, I think, Dale thought of these things in a fairly detailed way, and we thought it was worthwhile to bring his thoughts to the TAC itself, even though we didn't have a charter item on this particular area, and we didn't formally address a specific item for this. It does impact a lot of the different items that we would look at for spectrum sharing, and so we thought we'd give Dale just 5 minutes at the end here to address some of the comments and some of his perspective on the role of enforcement and security in shared spectrum. So Dale, hopefully you're there.
Yeah, Andy, can you hear me okay?
We can.
Oh, thank you. Well, good afternoon. I realize I'm between you and lunch, so I'll try to be brief. But I do appreciate being given the opportunity to compliment, I hope, the great work that the Spectrum Sharing Working Group has accomplished. And what I'll do is discuss a set of 6 thoughts or concerns that I hope will complement rather than duplicate the working group's excellent technical work. More specifically, I'll focus on the need for a risk-informed, systems-level perspective when it comes to spectrum sharing. Just last week, our working group co-chair, Andy Clegg, co-authored a wind forum report offering an advanced risk assessment framework using probabilistic modeling. My hope is that these brief remarks today will complement the wind forum's excellent work by focusing on what happens when interference does occur and how systems design and institutional response determine the ultimate outcome. In short, the challenge is not just how to share spectrum, but to how to share it safely. I will start making a comment that many, if not most, shared systems operate in complex overlapping environments where assumptions of full control or real-time cooperation often break down. Based on my experience, I know that radio interference is not rare and not always malicious. Sometimes it's reckless, sometimes it's due to negligence, sometimes it's the product of tightly coupled systems behaving in unexpected ways. In each case, what matters is how interference is detected, reported, interpreted, mitigated, and documented, both technically and institutionally. Going on, second, RF interference arises from many sources: poorly designed or non-compliant equipment, unexpected interactions, or deliberate disruption. It may originate from a nearby building, a distant continent, or even from space. It can be bursty, broadband, reactive, or cunningly disguised. Regardless of the cause, managing the interference requires not just technical diagnostics, but contextual judgment, investigative tools, and clear institutional pathways for response. As going on 3, as others have observed or emphasized, we still lack a consistent definition of harmful interference across many sharing contexts. It's often treated as binary. Either interference occurs or it doesn't, but in reality, harm is contextual. What's tolerable for a streaming video might be catastrophic for a public safety or a safety critical aviation link. We need frameworks that consider not just interference, whether interference is present, but its impact. Is it detectable, recoverable? Is there a margin in the system to absorb it? These are the kinds of questions that risk-informed sharing must grapple with, and that should inform our design of coordination protocols, sensing system, and especially enforcement mechanisms. Going on 4, RF interference often goes unreported. Sometimes it's transient, sometimes it's hard to localize, sometimes users don't know what happened. Or even if it does happen, they don't know who to call to complain about it. But even if it is reported, doesn't always make it to the right party or trigger a meaningful follow-up. This means our institutional visibility into the real-world interference is fragmented and partial at best. That limits our situational awareness, our ability to improve detection tools, and our capacity to calibrate policy and enforcement in a real world. 5, even when interference is identified, confirmed, and mitigated, longer-term accountability is often missing. Was it a faulty device, a rogue operator, a systemic configuration error? The follow-through varies widely. And while we should avoid heavy-handed regulatory regimes, we do need scalable mechanisms that distinguish between good faith actors, negligent actors, and malicious ones, and respond proportionately. This is especially true in dynamic sharing systems where new entrants rely on the integrity of shared environments to operate safely. 6, we've seen how even small disruptions can cascade, especially when complex systems depend on shared spectrum. Think of an emergency responder losing contact, a drone veering off course due to a spoof signal, a cargo operation delayed because telemetry failed. These failures don't always originate in the same place they cause harm. As we increase sharing, we also increase interdependence. And that means we need not only trusted communications environment, but faster detection, cross-domain coordination, and mechanism for shared responses. I understand that some of these concerns around resilience, systemic risk, and institutional agility will serve us in this afternoon's AI working group presentation. But let me conclude. I'd like to summarize 4 concerns that we've explored and how each might shape the next phase of the Council's work. First, as spectrum sharing becomes more dynamic, interference risks grow more complex and demand a more structured, systems-level approach. Second, many real-world disruptions don't stem from textbook spectrum conflicts, but from noisy environments, unintended interactions, or unclear accountability. These too must be part of the sharing conversation. Third, when interference does occur, the impact depends less on the signal itself than how quickly the disruption is detected, reported, classified, and addressed. We should evaluate our systems accordingly. Fourth, as availability targets rise, as availability targets rise, 5 nines or some, I've even heard talk of 6 nines or more, our current systems often fall short in enabling timely, coordinated mitigation across stakeholders. Addressing this gap requires engineering not just for uptime, but for graceful failure and shared responses. Finally, fifth, no matter how sophisticated our sharing frameworks, they will falter without meaningful enforcement, traceability, and incentives to behave well in congested environments. In short, spectrum sharing is only meaningful if we can share safely. Thank you, and I'm sorry I treated so badly into your lunch. I surely wish I was there.
Okay, great. Thank you, Dale. And I think that concludes our spectrum sharing working group presentation.
Unless there are any other questions that people have.
Any questions?
Okay, I'd just like to say thanks to the whole group for all of the contributions they provided.
Yeah, thanks, Andy and Manisha, and thanks to everyone who contributed. So procedurally, we do need to at least take a vote before we break for lunch on all of this material. So we've got the slides with the recommendations, as well as a group of white papers that were shared with the TAC members ahead of this meeting. So same as before, if folks could raise their hand for the ayes. Okay, and then lower them. Okay, any nays? Okay, all right, making it easy. All right, that passes, and we'll post those on the website as well. So that's the first two, and thanks again to the presenters. And now we will move on to our lunch break, and then we will have our AIML working group presentations after lunch. All right, thank you, everyone. Welcome back. If we could all get settled down and situated here in the room, please. Thank you. Martin, do you need some help? No, we'll get there. All right, everyone. We're making our way back from lunch. If we could get in our seats, please, settle down. Okay. Welcome back. Finishing the lunch break here in the room, and we have one more working group presentation before we conclude for the day. The next working group presentation is the Artificial Intelligence and Machine Learning Working Group. So I'll pass it over to Adam and Lisa, please.
Okay, are we set?
Yep.
While everybody's coming to a seat, I'll get kicked off here. So we're presenting on the AI Working Group Machine Learning, our findings today. We have quite a few slides. We're going to be going at a fairly fast clip. So just bear with us. This is all presented or distributed to all of you. So our agenda today, here we go. I'm pointing right at you, Martin, and it's not working. Whoops. There we go. Okay, so agenda today, we've got several topics. I'll be kicking off. Adam will be presenting. Unfortunately, Balaji could not be with us. He has been called to jury duty, but Adam's going to be stepping in. And then Ardavan will be presenting a section, and I will be closing. So let's start out with the composition of the group. We have conducted our work for the past 2 years. We had a sub-working group. Are you going to do that for me? There we go. We had a sub-working group that was led by Ardovan and Richard Kessler for at least part of that time, and we had several SMEs. All the presentations are in the appendix. So the AI working group members, this is here for reference. I'm certainly not going to read all the slides, but I just want to thank everyone for all the hard work you've done over the past year and a half. We have a softwareization sub-working group. Several folks participated in that. That was a great venue for us to have extra presenters and also get a lot of the work done. And recognition for several folks who contributed to the white paper that we are submitting and to this presentation. The entire group contributed quite a bit, but we wanted to specifically call out the folks on this list. In particular, Dale and Sachin contributed large sections in the white paper in their areas of expertise. We have our liaisons and observers, and again, won't read them. Several of you are here. And, I saw a guest join. So let's talk about the impacts of AI, ML, and softwareization on the FCC. So if we'll go forward, Adam, you still running?
Yep.
Are you taking, I think I'm doing this one, right?
Yep,
Yes.
yep.
So we ironically used AI to generate a little humor for us because at the end of a long day. But the key is now is the ideal time to embrace AI. So what are the impacts? This is a very high-level summary at the beginning, and I didn't say this up front, but what we are presenting is essentially the white paper, and we made our slides from the white paper so that this is a higher-level review. So the impacts are there's rapid technical progress on AI ML, there's new paradigms, there's maturation. This is coming along quickly is the large language models, the availability of foundational LLMs. In our earlier work, maybe back in the 2019, 2020, this was not nearly as mature, and it is definitely evolving. Understanding the importance of data, if we'll go to the next slide. So this is critical. We've really been highlighting this for several sessions. Extensive high-quality data is required to function effectively. This is going to require new data governance, policy regimes, best practice, and I will make a comment. I think we've heard that out of every working group, especially the spectrum management group, talking about, I guess in a summary, the world is changing and it's changing rapidly. Re-architecting network infrastructure. This is a very interesting trend, and it's going to impact us in many ways. So we're going from hardware devices into commodity hardware with general computing. Hardware is going to be commoditized. The value is going to show up in the software layer. It's going to be flexible, and it will have intelligence. But this is where we'll have to have not only just updated rules and ways to govern, it's really going to change how we think about things. And it's in ways that we're starting to see, but this is going to evolve and continue to evolve over the next years. So changes in the business model and value chains. So with the integration of this, and in particular the softwareization, we are going to go from a hardware world where it's a CapEx heavy model into more of a subscription model, software. We'll have faster innovation cycles. It will enable agility and a lot of differentiated services. And again, it requires rethinking how value is captured, measured, and regulated in this increasingly software-defined AI-native environment. This will significantly alter communication and usage patterns. So a couple of graphs, for the sake of time, because I want to make sure we leave plenty of time for some of the meat in this. Essentially, these charts are showing AI is happening, it's impacting the industry, it's creating industry growth, and the areas where it's happening the quickest right now are automation, language processing, and generative AI is clearly a top area. If you look at the hype cycle curve, there's many technologies and they vary in maturity. So you can't just look at AI as one monolithic thing. It's multiple different things, different levels of maturity. Some focused technologies have promise right now, and some larger and broader technologies are emerging rapidly. And we note here there's an America's AI Action Plan, which we reflected on in part of our work here. So with that, Adam, I think I'm turning this to you.
Okay. So for each of the sections that we'll be talking about, we put the charter question that goes along with it, and there are 4 different areas. It turns out there is a lot of overlap between them. So in context, what we thought is to take those common things, gather them together, and the best way to describe them is they're part of the transformation of the network. I'll be talking about this at a very high level here. There's a lot more detail that Ardavan will actually cover in one of the subsequent questions, okay, in one of the subsequent sections. But it really affects everything from the methodologies to the business models. There is an incredible inventory of tools that's available. Everything that goes under the labels of cyber physical systems, big data, data science, digital twins, edge and cloud computing, the Internet of Things, all of those things matter in this equation. Okay? If I were to take a look at sort of what's in the future for the FCC, computing, data, software, AI are likely to play important roles. I'm not going to go through the details of what's written here. I think that's going to be in the record. But in all of these, if I come down to a single point, it's that the spotlight will be on data much more than anything else, and also distributed systems. And I think Dale talked about that a little earlier in the day. If you look at the transformation of the network, it doesn't mean that all of these technologies are mature, that they are fully formed at this point. But if you take a look at what is actually going into the networks for various functionalities, this transformation is already well underway at this point. Okay? And that has consequences both for the quality of the network, its safety, ability to serve national needs, things along those lines. Okay? And there's a lot of, I would say, unforeseen things that one has to keep an eye out for. And historically, I think we've always found that to be the case. But if you look at the journey that we are on, there are a lot of labels people use. One is a zero-touch network, where everything is automated, autonomous, self-forming, things along those lines. There is a lot of stuff under the label of AI native, and so we'll be getting to those in some depth as we go along today. If you look at the value of data, again, probably the most important, one of the most important messages we could get across. Its use, its curation becomes important. What you find is what goes along with that data is the need for a lot of compute power, data centers, commodity hardware, things of that sort end up playing a much bigger role in the network. While you're creating more complexity in the way we build our networks, I think AI becomes an important tool for actually trying to tame that complexity. Okay? It doesn't mean that we are there at this point, but that is, I think, where we hope we end up essentially. So if we look at it in this particular area, there are 3 recommendations that we have. One is a uniform policy on AI, ML, computing, and data across the FCC, because this technology, I would say, leads to greater collaboration, breaking down of silos within organizations, things along those lines, and really the reuse of data for multiple purposes rather than having it sit in silos. So I think that becomes important. A lot of good things in the AI ML world, lots of controversies at the same time. How to deal with them, how to do this in a responsible way, again, should be something that's a uniform policy essentially. The second one is it's hard to really make headway with all of this without building capacity and capability for that AI ML future. So we have a recommendation related to that. And the last one is, again, sort of really focused on data. is a thorough review by the FCC of the role it wants to play vis-a-vis critical telecommunications data, how that data is gathered, how it's accessed, how it's processed, and I think at a top level, for almost all of the charter questions that we get, having a good way of dealing with all of this makes a difference, essentially. This also, I would say, applies not only to what the FCC does facing outward, but what it does within its internal processes. Okay, so I think with that, if I could hand it over back to you, Lisa. Okay.
I think I'm doing the next section.
Ah, okay, spectrum sharing. Okay, yes, you're correct. I'm going to do this one. Okay. So the next area is spectrum sharing. I think you heard some of that earlier in the spectrum sharing working group. In fact, Amit took a look at what the future may be. I would say this is another cut at it. And it's also important, I would say, in the context of cellular networks, 6G, things of that sort. I think we went through a lot of issues related to things like network slicing, things along those lines. It's a very different form of spectrum sharing, but also very relevant in some ways. Okay, and so to set the context, I think what we took a hard look at is not the near-term future, but I would say sort of the far-term future. And I would say that there are three things that are important in that. The first one is how to really achieve efficient utilization of the spectrum assigned to spectrum sharing, how to automate the processes that the SAS and things like that run today. So fully dynamic administration, real-time on real-time scales, essentially. Okay. And then lastly, a high degree of automation and autonomy, essentially, and how do you actually operate spectrum sharing regimes, look out for interference, and deal with all the issues of assignment and things along those lines. So there is a real challenge here, okay, and that is there's I think in the write-up from the Spectrum Sharing Working Group, looking at what happened in the past, all the way from white spaces to CBRS, okay? And it turns out this is actually a fairly tough problem to deal with, okay? We have a current regime for this. It works, I think it was a big breakthrough. Okay, at the same time, we're seeing a lot more heterogeneity in the network. NTNs interacting with terrestrial systems, things along those lines. I think some of that was covered. So this is a long journey to figure out, how to really regularize all of this and end up with a regime that, sort of fulfills the promise, essentially. And so if we look at the basic problem and ask, why is it difficult? I think during this term, both between the AI ML working group and the spectrum sharing working group, we heard from a number of SMEs, okay? And I think in previous years, we heard from folks who did the DARPA Spectrum Sharing Challenge, okay? And what you find is the following. In the AI ML world, there are a lot of folks who think we will throw some AI ML at a problem, okay, and some magic will happen and we'll get a good answer out of it, okay? When you start looking at the basics, okay, and I'm going to do this sort of for comparison, when you look at an LLM, it has a dimensionality of roughly 10 to the 12th. That's the number of tokens that goes into an LLM. Okay. It takes roughly a year to train one with access to a very large data center specifically built for the purpose of training the LLM. Okay? When you look at the problem of spectrum sharing and start looking at all the variations, all the things that affect it, we had a number of SMEs who actually went through the calculations, and their estimate is that it's roughly 10 to the 120th power. Okay? The level of data you would have to have if you want to use brute force use of AI and ML, okay, makes this unlikely for a long time to come. Okay? And so what happens is you need to really do the engineering, the systems engineering that figures out how do I chop up this problem into workable pieces, okay, where I may be able to apply AI and ML to some of those pieces, okay, but at the same time use other techniques along with AI and ML to actually end up with an answer. Okay? And again, I'm not going to go through all of the details. I think we heard from at least 3 SMEs trying to build digital twins, trying to do this kind of decomposition. I would say probably the most advanced we heard from is NVIDIA, that has a major effort in this area. They're not the only ones who are doing it. Okay? And they managed to take the propagation components of typical processing scheme, okay, where you're doing the channel estimation, things of that sort, and actually replace it with an AI ML core, okay? But an AI ML core that was specific to the location in which a base station was located, okay? And the use of other techniques. In this case, it was differential ray tracing. Okay, surprisingly enough, they found common hardware on which to run that, and were able to do that in real time. Okay, so it gives you hope that there is actually ways of chopping up these problems, and including a lot of the phenomenology, okay, that in fact makes spectrum sharing difficult. Okay, because if you look at it, you really need to have the right kind of building blocks to do this. Again, I'm not going to go into much detail on it, but I think the conclusion we came to is that this is a serious enough problem that if it really has value in the way we deal with our spectrum, it's actually worthwhile putting together a multidisciplinary task force that looks at all of the science aspects of this, looks at the policy aspects of this, okay, and comes to grips with what I think of as sort of the basic problem, okay, and that is how do you actually assign spectrum to a particular session and at the same time avoid interference with other things that may be out there, okay? And when you start looking at that in detail, everything matters. The agility of the antennas that you have and how you use them, how you control them, okay? So to us, this is a long journey, and I think having a long journey like that, it's worthwhile to put a task force together, build a roadmap, actually make enough of an investment that you can do some of the trade-offs in engineering on this, okay, and then have a long-term, stepwise program that says this is the way of bringing it to fruition, okay? And with that, let me turn it over to Lisa.
Okay, thanks, Adam. Thanks for running the slides. Now we'll talk about network safety, security, assurance, and performance. So the charter questions that we have, I think we need to go forward a little. Okay, charter questions. We had a few. I think we went. Sorry, folks, we're getting on the right slide. I think you need to go back about 3. No, you need to go back. You need to look up here.
Oh, my screen is frozen. Okay.
A couple of challenges over
There
here.
we go. Okay,
All
sorry
right.
about it. There we go.
Thanks. Evaluate the use of AI ML methods, this is the charter questions, and techniques applied to assuring the safety, security, and performance of the network equipment and operations. The second question is explore and evaluate AI-enabled networks, optimizing long convergence times, behavior of machine learning algorithms, and the challenges of AI networks in general. That's the gist of that question. And then how can AI/ML techniques be used to address the challenges of quality, availability, privacy, and security across multiple types of networks, wired and wireless, and also include data protection. So those are the questions. We came at this, there was some overlap, as Adam had said, so we looked at this as a topic as a whole. And what are some of the technology trends and adoption? AI/ML are integral to modern communications networks. It enhances our safety, security, assurance, and performance. What's really important is real-time automation, optimization, energy efficiency is ever increasing and it's important. And we're starting to see an emergence, this has been discussed for a while, but intent-based control. I think this is really starting to come to real fruition because we're starting to hear SMEs talk about it and in real applications. We want to highlight an area of importance. This is included in the paper at length. In rural broadband deployments, subscriber density is low, ROI is limited. AI can assist through that life cycle, help it to be more efficient, and to help us get further broadband reach. The need for new governance policies. I talked about this a little in the beginning. We're going into a softwareized world and AI/ML world, and so data quality will become more and more important. We talked about LLMs, the data required, convergence stability, government frameworks that also ensure ethical, reliable use, and redefining the network. So as we evolve toward 6G, like some of the technology we've heard today, distributed multi-layered architectures, AI is critical for end-to-end orchestration, spectrum management, and resilience. So we need coordinated standards, robust policy, and a lot of stakeholder collaboration, which you'll see that show up in our recommendations, so that adoption strengthens while not compromising the network infrastructure. So on to the recommendations. I think we have 4. The first one is to, again, this gets at the collaboration, promote AI-enabled network efficiency through collaboration and access to key resources. So actively encourage adoption of these methods to enhance the performance and the spectrum efficiency. And I think this overlaps a little bit with the other working group and aligns nicely. I know we attended a lot of their meetings and that group attended ours. Fostering public-private partnerships to accelerate research and deployment. The second recommendation, promote interoperability across the telecommunications ecosystem. I think we're about to go forward one. There we go. Support interoperability across multiple modalities, fiber, satellite, wireless, local last mile, a cross-sector dialogue, and it's important to note voluntary standards development. So a lot of the spirit of these recommendations aren't about regulations, they are about collaboration, cooperation, and fostering industry groups to work together. Finally, the FCC should convene an industry-led consortium, create a vetted telecommunications-focused LLM to support interoperable and safe AI. Third recommendation is support the development of AI-aware network reliability and safety frameworks. So encourage the creation of AI-informed reliability models, account for the increasing softwareization, and the deployment of intelligent automation. The infrastructure is going to become more and more automated as time goes. And as this evolves, are we okay? Okay. As we have more softwareization. So take a proactive approach, safeguard the public interest as telecommunications systems evolve. They'll become more complex, yet more adaptive. And the final recommendation is to promote a telecommunication-specific AI security framework. Support the development of telecom-specific cybersecurity framework, address the AI-enabled systems, coordinate with relevant federal agencies, voluntary certification pathways for key network components. Involve especially the software-defined AI-driven functions, bolster the supply chain and operational integrity. So we see here the FCC can have a real role to play in a telecommunications-specific framework. And, AI as we all know, is a very large topic. And the more specific subsets of it get, the quicker we can get where we need to go and the more focused it will be. And I think with that, Adam, I am turning it back to you.
Okay. So this section comes from Balaji. Again, he had help from quite a few people. And it's really looking at the role of AI and ML in testing regimes and certifications. So if I were to take a look at the charter questions, what approaches should be taken, if any, on testing and certification of AI and ML, softwareization of network components, capabilities, and equipment. Okay? And I think the way we dealt with this is to have two different aspects. The first is the testing of AI and ML components used in the network itself, okay? And the second part was the use of AI and ML methods and techniques to improve the testing of the network. I think we start off with a number of observations, okay? And the first one is really the characteristics of AI native networks. What it means to put AI into the network itself, and the testing of those AI components used in the network. Okay, if you take a look at where we seem to be going, this is part of the transformation, is that the network itself involves extensive virtualization and softwareization, leading to a distributed asset and significantly larger number of interfaces. Okay? And in fact, if I remember from one of our presentations last year, if you look at the progression of the number of parameters that you have in 3G, 4G, 5G, and hard to tell what will happen in 6G, that number has probably doubled almost every generation and stands somewhere between 7,000 and 8,000 at this point. Okay, it's an incredible number, essentially. Okay? So if you look at all of this and you want to be able to meet your requirements, performance metrics, the amount of massive computation storage that's involved, you find that the AI functions tend to be diffused across various components and subsystems, okay? And that has implications for reliability and stability of the network. In some sense, I would say what Dale talked about earlier sort of echoes that, okay? And ending up with a formal framework to actually be able to tell what risk you're running also becomes important, and in some sense that is what you are actually testing for. The next thing is testing and policy regimes. The existing certification processes are geared towards individual devices rather than holistic end-to-end system views. Okay? And that is a very big change, essentially. That expansive view, okay, is necessary for understanding the complexities of AI and ML in the network. That in turn requires testing for data quality, completeness of data coverage, security, robustness, a whole bunch of abilities essentially, okay? And it actually ends up requiring a very different kind of testing and policy regime than what we have when everything is device oriented. So that requires a transition in mindset. I think if I look at some of the rules that we have today, it'll talk about the level of EIRP I have, things of that sort. I think what this really transitions to is even those components are driven by software. If that software isn't working right, you'll get emissions where you don't expect them. Okay, and so it's a very, very different view, and that is one of sort of concentrating on behaviors. Okay. If I could go on to the next one. And then the next one is changing the nature of testing regimes themselves. I'm not going to go through, read all of this, but essentially the use of natural languages, things of that sort, so you can actually achieve a reasonable level of coverage, do that, and work in this highly complex space becomes very important. Okay? So intent-driven systems, things of that sort, become one of the tools that is important in that. Then is the role of AI and ML driven digital twins, where we try putting models together. It's the behavior of those models that matters. If those models don't work right, you will not have a stable network if they're part of your control chain. So again, how do you create low-risk testing that in fact allows you to deal with those kind of constructs? At the same time, you can actually use digital twins to do sort of speculative testing of how would the network react to this and that, and have some faith that it's actually giving you useful information. So if I were to turn to, I'd say, sort of the meat out of all of this, I think I seem to have skipped too far. Okay. There are roughly 10 recommendations that we have, and they're fairly granular. You can think of them as really one recommendation with 10 different pieces to it. But the first one is to really establish an internal FCC organization focused on AI, ML, and software testing. Okay. The second part of this, am I advancing to two? Okay. Is establish a testing framework specific to AI and ML software and telecom. I think there are a lot of lessons learned from what other organizations have done. There are probably dozens of organizations that have actually created such frameworks in other fields. Lots of lessons learned there, but it's for the development of standards, it's for certification, and it's creating some form of, I would say, guidelines, things of that sort on best practices. Next one, okay. Define testing and evaluation protocols, just as we do for device-oriented testing. What does it mean to test at a module level all the way to a systems level, essentially? Flush out edge cases, things of that sort. To have a certification and auditing program that accompanies this. Next item. Definitely that risk management and safety and assurance framework. Again, lots of bits and pieces to this. The next one is foster industry and research community collaboration. Stuff is actually moving at a fairly fast pace. The tools are changing, and being able to bring in new technologies, things of that sort, and doing this collaboratively with other organizations makes a tremendous difference, essentially. If you start taking a look at the components of what actually makes up the network, not everything is under the remit of the FCC. So having a good, strong interagency collaboration and coordination becomes fairly important. If I were to take a look at, let's say, the silicon that ends up in telecommunications, there are others who have a big stake in it, other funders for it within the government. So again, that kind of coordination becomes important. The next one is an update on spectrum and infrastructure policies, because the infrastructure changes in nature considerably. Reporting and data sharing becomes important, common lessons learned across the industry, and then very lastly, development of the FCC's internal capabilities. I think it echoes one of the previous recommendations. Okay? I think with that, what I would like to do is turn it over to Ardavan.
Thank you. Adam, could you please?
Yep, I will. Thank you. I'm not doing a great job of it, but I will
That's
try.
right. Oh, thank you. Thank you, Adam. Before I start, I wanted to thank all the subject matter experts who helped us with their contributions on these final report sections. Misha Doller from Ericsson, Tian Lan from GW, Tim O'Shea from DeepSeek. Tian and Tim are present here. Thank you. And Yusuf Mai from NTT. I'm going to skip the charter questions as we have included a note about the context of the findings and recommendations in this chapter as they relate to these charter questions. So it turns out the matters related to the FCC charter questions actually tie into bigger AI and ML computing issues. And the good news is that a lot of progress has already been made thanks to expert work and massive fundings and government support. And the next set of slides discuss these developments as they relate to the charter questions. So we are going to cover 4 sections of findings and recommendations. The first section discusses digital transformation and associated virtualization. The second section covers softwareization and advances in network control and management functionality. The third section discusses evolving business models and policies. And in the fourth section, we're going to cover implications for the FCC. By the way, before I go through the findings and recommendations, I want to mention that for each of the topics and subject areas, we have tried to capture the challenges and value propositions in the findings, and the recommendations are focusing on how to address these challenges and achieve the value propositions. With that, in the digital transformation section, we want to highlight that digital transformation powered by technologies like virtualization and software-defined networks, generative AI, is changing the wireless industry. And digital transformation also requires a mindset shift from intuition and legacy processes to data-driven decision-making. I should also mention that some of these findings and recommendations are similar to the previous sections, as Adam mentioned. So here we've pointed out a few areas that are really pushing digital transformation forward. These are like powerful new computing and storage options, massive amounts of data, and the growing use of advanced analytics and AI. And one of the key tech tools making all this possible is virtualization. In simple terms, virtualization means swapping out physical network hardware for software-based versions. And this change brings big benefits like cost savings, being more flexible and more agile. Yeah, we can move to the next one. So based on what we found, here's a few recommendations we've made. First, we think that it's important to help modernize the digital infrastructure. So we are recommending that the FCC teams up with industry players to focus on building a national network that is strong, flexible, and can easily scale. That way, it will be ready to handle all the new and evolving services coming our way. Here we've provided a bit more details on agent-based and orchestration technologies regarding the previous text. So I'm going to skip this slide and move to the next recommendation. So our second recommendation is to focus on 3 main points. The first one is that we are suggesting FCC to encourage everyone to use advanced analytics and real-time monitoring tools more widely. And the next point is that it's important to invest in people and organizations, making sure the telecom sector has the right skills and flexible processes to keep up with fast digital evolution. And lastly, here we are recommending the FCC to set up platforms where operators, vendors, regulators, and universities can talk and share ideas, and this will help the ecosystem to learn from each other and innovate together. And can we move to the next one? Yeah, thank you. The last recommendation here is that the FCC should make sure regulations keep up with new technology. Specifically, we suggest putting together clear guidelines that cover everything about data, from how it's collected and used to how it's stored and eventually even deleted. And of course, all of this needs to happen while protecting privacy, security, and making sure different systems can work together smoothly. Here we are also pointing out that having a shared system for how equipment vendors handle and share data will help make things overall more reliable and secure. Now, I would like to pause for a minute here to make a few important points about this last recommendation. First point is that by regulation here we mean light touch regulation. And the second point is that we thought some amount of regulation in this case is needed because the absence of any regulation, ambiguity, for example, could be problematic. And when there are no rules, things could fall apart. And there's also an argument related to interoperability, which I will cover later. So our second section talks about digitization, softwareization, and using AI in networks. Here are a few key points we've pulled together. The first point is that digitization is changing fixed network functions into dynamic and programmable ones. And this brings a lot of flexibility, efficiency, and cost savings in how networks are run and operated. And more specifically, software-based virtualized networks offer a number of benefits. They can be set up quickly, resources can be adjusted easily, upgrades are simpler, and importantly, they make it easy to work with new AI and machine learning tools. Here we've highlighted two specific examples of software-centric implementations. One of them is intent-based networks, or IBNs, which Lisa also mentioned, and the other is multi-tenancy deployments. IBNs use generative AI and real-time performance tracking to make managing networks easier. And since there are more and more different network applications, IBNs would help handle all that complexity really well. Multi-tenancy lets one physical network support multiple virtual networks, and that helps get the most out of resources. These virtual networks serve different sectors like healthcare, manufacturing, and public services. And while I've mentioned all these specific examples, it's also important to point out how crucial it is for these solutions to be also technically mature. If you're aiming for highly automated and resilient networks, then making sure that these technologies are mature, well developed, and reliable is just as important. And here are three recommendations based on what we found. The first one is that we are suggesting the FCC to take an active role in pushing for faster rollout of virtualization across the industry. Doing this will help set the stage for using advanced analytics and AI to make networks smarter and more efficient. I can move to the end. The second recommendation is for the FCC to put policies in place that encourage investments in both edge and centralized computing. This kind of balanced approach helps keep US competitive in the global telecom space. Yeah, can we move to the next one? Thank you. Our third recommendation is for the FCC to take a more hands-on role in helping the industry to move to unified AI-native network management solutions. At the same time, it's important that this guidance doesn't get in the way of how the markets operate. So with that, moving on to the third section. Our third section looks at how business models and policies are evolving. And here are a few takeaways. First one, bringing AI and machine learning into the mix means moving toward a fully software-based approach. We've also emphasized how important it is to connect software components with business processes and workflows so everything works smoothly together. And also, we wanted to point out one big trend is automation of management systems. And that's helping networks react faster to changes and perform better overall. Another takeaway is that scalable compute and storage are becoming a really important part of modern telecom infrastructure. And this includes layered setups like embedded systems, edge computing, and cloud-based solutions. These multi-tiered architectures help balance things like latency, speed, and costs across the network. Here we've also pointed out several other key supporting technologies like strong security frameworks, IoT management tools, software-defined wide access networks, SD-WAN, network slicing, and compute accelerators. And all of these play a role in making networks smarter and more efficient. And one last but really important point we've noted here is that modern networks are putting users at the center of innovation. And they're doing this through means like dynamic resource allocation, advanced analytics, and automation. The benefits are smoother, more reliable, and high quality experience for users. And here are a few recommendations based on the findings. Given the importance of interoperability in the national network ecosystem, our first recommendation is for the FCC to lead efforts to promote standards that make sure all parts of the network work well together. And this would help cut down on fragmentation, lower integration costs, and make it easier to offer complete bundled services. And our second recommendation is for the FCC to advocate for policies that encourage investment in diversified multi-tiered compute and storage infrastructure. And as we mentioned earlier, this kind of flexible infrastructure is key to supporting advanced applications, real-time analytics, and services that need a lot of compute power and speed. Our third recommendation is for the FCC to create policies that focus on making network services more accessible, secure, and transparent. And this is going to help to make sure that consumers all across the country are uniformly protected and supported. So our final section looks at what all of this means for the FCC and what's the impact on FCC. And we've made a few observations here. We are seeing a big shift from hardware-based networks to software-defined ones, and that's changing the whole telecom landscape. And if the FCC supports policies that push for advanced infrastructure and faster innovation, it could help keep the US at the forefront of global tech and innovation. Adam, can we move on next? One point we really want to highlight is that not having interoperability comes with a big cost. When networks are fragmented or systems don't work well together, it can drive up expenses, create security risk, and hurt overall performance. And we've also noticed that generative AI and machine learning are set to transform how networks are managed. To really make the most out of that, it's important to have clear frameworks in place to keep things transparent, accountable, and ethical. So in this finding, we've pointed out the value of having full end-to-end observability in the networks powered by AI. We are also suggesting that dedicated task forces or advisory groups be set up to regularly review and update policies and best practices as things are evolving. We also recognize that industries like agriculture, automotive, healthcare, and law enforcement will be heavily impacted. So it's important to make sure their different needs are met, and this helps to ensure fair access to quality services, close the digital divide, and encourage innovation across sectors. We've got a few recommendations here as well. First, we recommend that the FCC to promote standards that ensure seamless interoperability, that everything works together smoothly, especially when it comes to integrating AI and machine learning. This will help keep US networks competitive on a global scale and ready for whatever tech comes next. Another key recommendation is for the FCC to create a flexible, forward-looking regulatory framework. And to make that happen, we suggest setting up dedicated task forces or advisory groups that can regularly review and quickly adjust policies as things change. And again, emphasizing here also on a light touch regulation. And our final recommendation is for the FCC to actively encourage partnerships between network operators, equipment vendors, key industries, and government agencies. And the final note is that we hope with these recommendations that the FCC can help ensure the US stays ahead globally when it comes to research, innovation, and industry solutions. So any questions about these sections? Should we open up to questions? No?
Let's get through closing.
Or
Let's do the closing, and then we'll open up for
Sure.
questions and
Okay.
discussion, okay?
Sure.
Okay, so I'll power us through a fairly rapid closing so we have enough time left for questions. So closing remarks, AI and softwareization are inevitable and accelerating. I think you've heard that theme woven throughout today. A lot of positive outcomes for national competitiveness, spectrum efficiency, but there's issues that have to be solved, and as an industry we have to solve it. Fragmented adoption across the stack. Different parts of the network will evolve in different ways and at different times, and interoperability will be key. Next slide. Lack of standardized models and benchmarks. There isn't really a consistent way to evaluate AI performance and especially explainability and safety in telecom environments. A lot of vendors are making progress here, but it's, again, back to this interoperability, moving forward together. For this industry to evolve, this will be important. Some new things that will be happening in the network architecture. We touched on it earlier, edge AI and distributed intelligence. AI will be closer and closer to the network edge, but will exist all throughout the network. We'll have ultra-low latency, but also high-end computing. The next slide talks about cloud-native network functions and microservices. This has been a trend that has been coming for a long time. It's been in existence, but it continues to evolve, and AI will only make it evolve more quickly. Artavan talked quite a bit about intent-based networking, so we can put high-level business and operational intent into the network actions. AI-optimized silicon and specialized hardware. I talked about that up in the introduction, and we see it going in maybe two different ways in a way. So if you look at commoditized network functions with software value, that'll be one way. There also will be customized ASICs that are very power efficient and processed directly within the infrastructure. A lot of exciting developments there. And then data challenges. So today we've talked about data. We've talked about it's siloed, incomplete, could be poor quality. In some of our past writings with the working group, we talked a lot about federated data models, privacy-aware learning architectures, and helping to mature that and to help that be interoperable as well. Advanced telemetry and observability. Rich real-time telemetry will be important, and we threw in a future outlook of quantum computing because I think this presentation wouldn't be complete without mentioning it. So it's been very early stages, but there will be a lot of development there. We haven't even touched on that in a lot of our findings yet. We just wanted to give a nod to it. So in closing, well, you skipped over our final slide. You gave away the joke. No, the FCC should foster an ecosystem that accelerates the integration of AI, ML, softwareization across a variety of data environments, network architectures, and support voluntary industry collaboration, removing barriers, in alignment with an action plan so that we can have a competitive national network. And I think with that, we're finished. We'll do our closing slide. So now for questions.
Okay.
Henning?
Yeah, thank you. You're obviously trying to cover a pretty broad spectrum and so, but I admit I was confused throughout because it wasn't quite clear. You always use the term AI/ML. In some cases, these were clearly like in the coding and software development. You're talking about typical large language model coding approaches. In others, it sounded much more like traditional, if you want to call it that, AI machine learning models, convolutional neural networks, random forests, and so on that learn from proprietary data sets that are local to the application. And so I was confused throughout which one in each case you were talking about. So I think it would help to make this a bit more concrete going forward. The second one has obviously been on the software development side, which is a huge challenge based on what we heard earlier for particular cellular network, but really for all kinds of complex networks. What would you see, or what did the group see as being the fundamental differences to the kind of efforts that are used by many large software-heavy organizations to use machine learning techniques, primarily LLM-based in that case, to generate software, kind of a vibe coding notion? I have to admit, I shudder at the thought of a vibe-coded 6G implementation.
So Henning, I think you made a couple of statements, and maybe there's a question sort of buried in there. I think if I take a look at what we've actually written up, one of the things we have pointed to is all of the organizations that already exist for governance of AI in other fields. That was done both in the testing section, in Artavan's section, and I think in Lisa's section. Okay? So there are organizations, for example, like SCI at Carnegie Mellon. They have a robust program to actually bring AI into their framework. Okay? The reason they're important is they also are the certification body for software, okay? And so they're working very hard on incorporating best practices for AI-driven software development, okay? I can point to probably 3 or 4 other organizations doing something very similar, okay? So to me, I would say, you know, the FCC is not going to be the center of how the center of the universe and how those policies are actually put together, okay? And that is why we put so much stress on collaboration with others who are already doing that, okay? Does that answer your question?
Thank you. It's certainly a start.
Yep.
Bijoy?
I think like a week ago, the US government had issued the AI plan,
Yep.
which included areas. I'm trying to understand the intersection of that, which was more focused on exporting full stack, building out data centers, more protection of how the IP was being created, versus this FCC work group recommendation that goes into all the things, how data is collected. How do you see these two work together?
Well, so if you look at it, that plan actually had 3 aspects to it. One is to make sure there's infrastructure. I think we sort of addressed that because that's important. The second is workforce development, okay, which means building up capabilities, things along those lines, okay? And the third is innovation around new uses of AI for applications, okay? And I think we covered that in the sense that we recognize that a lot of the requirements of what the network has to do in the future isn't just the telecommunication piece, it's actually requirements, okay, from applications, okay? And I think as we heard earlier, both in the spectrum sharing working group and in the 6G working group, it's really looking at what use cases are important or which ones are not, okay? And how do you then have a flexible enough framework that can accommodate those? So I would say it actually parallels a lot of what's in that plan, okay?
And I would add, I don't see that any of the recommendations actually are in conflict with it. They're more of a focused subset of it, whereas the America's AI Action Plan is a broader scope.
Yeah, I wanted to mention that I did actually check against that because I wanted to make sure that our recommendations doesn't have any conflict. One thing that actually Lisa and Adam mentioned, the White House Action Plan covers a more broad area. We have been more focused on telecom and FCC.
And let me just give you, again, sort of an example. One of the issues is security, cybersecurity issues along those lines. What you will find is the lead agency for doing that has actually been NIST. They have a whole cybersecurity network. When you actually look at it, it's general. Each vertical actually has to go through and develop a vertical specific version of it, okay? And so for us, it would be taking all of these frameworks and looking at where do they cover this vertical, where do they miss it, what are the pieces that are specific to telecommunications, and concentrate on that.
Yes, to be clear, I wasn't suggesting there's a conflict. I was asking more along, given that action plan and the work group recommendations, how do we ensure that it both works together so that the execution of it happens?
Collaboration, coordination.
Madeline.
Thanks. You talked a lot about data and a lot about the data that would be available to an AI/ML that's operating in the network. And then there's conversations about data privacy.
Mm-hmm.
Presumably, what data is the network then contributing to which LLMs? And I'm wondering if the group talked a lot about which data should be protected and or private and or which data should be available to all LLMs for all purposes. I'm just curious about that.
I would say we did not on purpose actually address that, okay? And let me again go through the reason, okay? There are a lot of things we could have spent our time on, okay? One of the things is to survey all of the organizations that are already working those issues, okay? And I can tell you, if you go through that, I think we covered it actually in our previous report last year, the year before, okay, is the EU passed an AI Act. Okay? It has a framework in it, it's fairly specific. The Chinese did something very similar, okay? We tend not to have these large framework laws, okay? And so what you find is that a lot of the states have passed their own at this point, okay? And I would say at some point one has to start taking a look at, okay, should there be a national law? We thought that was outside the scope of what we were addressing, okay? Okay. But I'll point out that there are a lot of organizations looking at those issues, okay? And so when I look at, let's say, testing of AI, and you look at the section, I think, written up by Balaji, it actually has 6 examples from other verticals, like healthcare, okay, where you have all kinds, you know, you have the HIPAA Act, things of that sort, okay, is to take a hard look at those before we do something in telecom, okay? I hope that makes sense, okay?
We've got a question from Tom online.
Yeah.
Thank you all for doing such broad and deep work on this. I do have a question with regard to the task force recommendation you're making. Are you recommending that the FCC heads up that task force, or some other, leadership?
Okay, so if you look at the specific language, okay, what we said is whether it's the FCC or whether it's hosted by another government or neutral organization is quite okay. Okay? And in fact, when I look at it, you have the Wireless Innovation Forum, you have organizations like ADIS. There are many, many different ways in which the FCC could go forward and exercise the creation of that task force. Okay. What I think is sort of missing on the on the scene, okay, and I don't think it's just me, is there have been efforts. There's Spectrum X, okay, that the NSF funded, okay. There are other things. But in the end, you really need critical funding, an engineering approach, and enough resources to actually get something done. Okay? A good example of something that was very effective was something like the IETF, which did it for the internet. Okay? If you want to take this area seriously, that kind of funding in the end has to show up to actually make progress. This is not a simple problem. Okay? And so what we said is, the first step is, in the least, put together a roadmap, flush out the issues, make sure that you have enough people at the table who have a say in this, okay? Articulate it, and then hopefully that actually makes the case for some degree of national funding.
Okay.
That's a very good question, but without resources, I don't think we make progress on these things.
Doug.
As somebody who's been living in ground zero of AI for about the last 9 months, I find it helpful to break what you guys ended up having as one large amalgam into 3 smaller pieces. AI over the network, AI in the network, and AI behind the network. We make our own chips. You're 100% right, Lisa. We're already using AI in chip design. You can't stay current if you're not doing that. Excuse me. So when you think about how you're doing certain kinds of things, certain things are extremely important to be regulated and accommodated so that they work together. Other things we shouldn't touch, and other things we need to think about, like touch. And so there's going to be a balance aspect in that.
Yes.
Yes.
Shahid?
All right. I guess, first, nice job there, everybody. Well done. A very extensive report. Question for Ardavan and Adam, I guess. So in the software world, there's a lot of, there's a whole shift between SaaS and going to agentic AI, right? So Salesforce has pretty much moved on, ServiceNow and other companies. So I'm just wondering if in your research and in your surveys, was there any discussion around how OSS, BSS can effectively be replaced by agentic AI?
Yes, yeah. No, and let me put it this way. I think we cover agentic AI in the discussions, okay? And I would say it's not without its problems, because if you have well-defined, repeatable tasks that are limited, I suspect we'll all agree it works well. When you have many tasks and many agents, I think people are counting on that intent-based networking as the means of orchestrating and moderating so there are no bad interactions, okay? I would say the science of that is not mature at this point. Okay? And so when I look at Salesforce and you end up with a module doing something very, very specific, works like a charm, okay? Once you get a string of AI agents to interact with each other, that's a much tougher area at this point, okay? Lots of investment, so there may be rapid progress, but there are some very basic problems that have not been worked out. Okay?
Yeah,
And this is sort of the hard part with this kind of technology, is you don't want to inhibit it from the innovation that's going on, okay? But in terms of doing full deployments with stuff that is not mature, that has its problems at this point. Okay? And so if I were to, again, do a survey of white papers, whether it's Deloitte, Accenture, McKinsey, et cetera, I think there's a body of literature that covers this specific issue.
yeah, I wanted to add another comment on a related area is also databases, because it relates to one of the charter questions, the ULS. And in fact, we had discussions with Shahid Ahmed, who's on the TAC, and he was telling us that NTT has a big project that he's actually working on using AI to replace all their databases. All their databases.
Yeah.
So,
make them AI live.
Yeah, yeah.
So you can do a
using
smart
AI.
query, and it'll go and get stuff from you wherever it resides.
Yeah. And AI would do it. And on that note, we in the report we are referring to it for ULS, for example. Same story with FCC and all the data that FCC has in databases, and AI could be very valuable in solving those.
And in fact, if I were to build the first agent, it's when you look at the database and you find here are incomplete fields, here are contradictions, all of that. The agent goes out to the person who supplied the data and bugs the living daylights out of them. Okay? That's a good agent. Okay. Yeah. It's called the nag.
Greg.
Well, let me start by saying I don't want to sound like I'm channeling anybody, but we should thank Dale for sensitizing us to the ability of anyone to take good technology and make it bad. In this case, the committee, the working group, pretty well mentioned how the database is very important. But what worries me a little bit is what happens if an AI tool is trained to an incomplete database or a biased database, and a bad person of some kind manages to keep it that way, to bias the results of the AI, and everyone could be blind to that. So, and I know we talked about this, but maybe something for next year, for future, is development of tools that can keep checking AI engines to make sure that they are covering the entire existing database.
No. So you are right on the money, okay, with that question or statement. There is a phenomenon called data poisoning, where somebody maliciously inserts data into a stream, okay? And you get odd results out of the inference engines, things of that sort, okay? And I would say at the same time, that's a general problem with AI, and there are many bodies working on those issues. I'm not sure that the FCC has is the center of competency in how to do that, okay? And so again, the appeal would be, how do you coordinate and work with other organizations that are doing it, whether in the government or outside, okay? But those are real issues because AI can be used in a very malicious way. Okay? I can tell you if I had an AI agent doing robocalls, you wouldn't like it. Okay? And yes, there are already people doing that. Okay? And not only doing that, they're actually using Gen AI to fake a voice that'll have an impact on you. Okay? So yes, those are all real issues, and yes, they have to be dealt with. Okay? And it's good scope for additional things to be looking at.
Let me just follow up on that. You were talking, and I started talking about general AI issues that are serious. But where the FCC comes in, if the FCC were to certify or approve an AI engine to run the network, and then that AI engine were to be modified somehow, is the FCC or the certifier then responsible to make sure that the database continues to be certified?
So you will find we have inside the white paper, there's a fairly lengthy section, I would say written by Dale, okay? And it deals with some of the issues you just brought up, and I would say a much more general issue, okay? And that is, there is a lot of hype around AI, and as Dale points out, there is a price to be paid for that, okay? And so when you start looking at it, like everything else, none of this stuff is perfect at this point, okay? But if you look at it sort of writ large, it's actually advanced in an incredible way in a very short period of time. So there's something that says one should be hopeful that many of these problems will be resolved, but it also means that some resources have to be allocated to resolving them. And in the governance and regulatory structure, I would say, in the end, there have to be some penalties and an enforcement mechanism that people don't go down this, down the path of doing things that are actually destructive. Okay? And we did not address that in this term. Okay? Yep.
Okay, not seeing any more questions, so we've got the slides that contain the recommendations from the group, as well as a white paper that effectively say the same recommendations, circulated a version of that to everyone. So call for a vote for those two. If we can go for the ayes first again. Raise your hands, please. Okay. Any nays? Okay. Well, I think that's it then. So as far as concluding, just want to thank everyone for all the hard work that went into this. I know it's been a long couple of years here, so I really appreciate all the work that went into these final recommendations, and we'll definitely be taking it into consideration. We'll make sure we post the materials after the meeting onto the website. And just another call and a reminder for the open application period for the membership that's closes on October 3rd. Otherwise, we'll probably pick this up sometime next year once the FCC has a chance to consider all the membership applications, and you'll see other notices for it later on. So otherwise, thank you, and Amit, go ahead.
Just wanted to acknowledge all the hard work that our group leaders and our government representatives have done, without whom all this effort would not have been possible. So thank you all very much.
Thank you. Okay, unless there's any other comments, then it's time to close the meeting. So, yes. Sure, go ahead, Greg.
Last night at dinner, we talked about
You got Mike.
a way to
Oh,
search to see if which of these recommendations have been applied
yeah,
by the FCC.
yeah.
And there's a website that does it. I wonder if you could tell everybody.
Oh, yeah, so just with any other Federal Advisory Committee Act group, there's a website, facadatabase.org, but it's for any advisory committee across the government that tracks the total number of recommendations provided by any advisory committee, as well as the number of recommendations that the agency has acted on. It includes the membership information and the charter and membership balance plan and all the other relevant materials, which is administrative. So that's all available publicly. Yeah. Yeah. Okay, all right, thanks.